Yeah, I don't really know exactly what I want to get done today. I figured it'd just be kind of fun to stream. There's some projects that I've kind of had in the back of my mind, and they make more sense as a stream project than as a video. So we're gonna try some of that. Um, the two things that I kind of have in my mind are our Minecraft mod, which we'll probably get to later, and then platforming. Mario Maker has made me want to make a platformer. I've Platformers are just one of those things that I think are you kind of everybody likes. Maybe it's just me, but I'm thinking 2D platformer with some extra twists, and we'll see where that ends up going. But yeah, I figure we can just start with a 2D project, and we'll just call it platforming. I might already have a project called this, so this might not work. Do we want any of the new pipelines? I don't actually know. Um, I don't think so, because mostly what we're working on here is not graphical. We're going to be mostly working with boxes just so we can get the physics working, because a lot of this is going to be like custom physics stuff, and so I don't really want to play too much with the rendering stuff, and so I think adding those is just going to make that more complicated. So we're going to avoid that for now. Let's see here. Platforming 2D, sure. Yeah. So the goal here is just to get like the basic physics of platforming working, which is not easy, because platformers have probably some of the harder physics sides, and they're not something that I'm super familiar with. Yes. So Celeste is also a big inspiration there. That's a game that I only got into recently, mostly because I ended up following a bunch of the creators on Twitter, and didn't realize it, and then saw the game being played at a Games Done Quick, and was like, oh, that looks like fun, and then beat like half of it, and then didn't beat the rest. um, but that will probably feature in a little bit as well. But I feel like Celeste is, I don't know if I want to say like less approachable, but it's a very different style than like Mario. And so there's like two different platforming styles, I guess, and I don't know which one I like more. Celeste feels amazing though. I think that's the coolest part about it, is like you feel awesome when you're playing Celeste. Mario, you just feel clumsy, and I don't know if that's a good thing, but still, we'll figure it out. So here's our empty project. Let's just get like the most basic scene we can. So we're gonna create a cube, and move it down just a bit. And we're going to be working in 2D, so we need a box collider, 2D one, and we can just stretch this out. Again, none of this is exact. It doesn't need to be, because we're just exploring physics. So yeah. We don't particularly care too much about it. We just need it to look all right. Yeah, I was hoping to get to this stream a little bit sooner, because the channel's like audience is kind of split between Europe and the United States, and then a few other people scattered around the rest of the world. But a majority of it is like Europe and then the United States. But at least for Europe, this will be like 11 p.m. Which, and that's for assuming you're on the west side of Europe. So streaming is hard because west coast of the United States, but we'll try to make it work. Hopefully, I can start doing these a little bit earlier. I think I'm hoping that would help. So like 3 or 4 hours earlier than this. But there will be a VOD, so you can loop back and see what we did if that's something you're interested in. All right, cube. Let's make this a something. What do we want to do with this? We can just leave it, can't we? It doesn't have a rigid body, so it's not going to go anywhere. So that should be fine. Let's copy it. Did I want to do that? I don't think I did. But we can make a 1x1 cube, and that. Yeah, midnight. Okay, great. So let's make a cube, and let's do the first thing. Let's make it fall, and so you won't be able to control it. You won't be able to do anything with it. But we want this cube to be able to fall. So I do a little bit of both. When I'm starting a project, it's either like there is this specific thing that I kind of want to capture, or there's a specific like problem, I guess. Um, but typically, like I have a mechanic. Like for this game, it's actually very much like Redstone inspired from Minecraft, and sort of with some like Factorio stuff as well. Where I'm intending to take this specific project is if you're familiar with the old XKCD Red Spiders thing. There was effectively a comic that was showing a whole bunch of like red spiders kind of climbing up this complex platform, and there were a bunch of different tools being used to do that. What I'm hoping to do is be able to recreate that so that you can actually have a variety of different things that you can build in the level and connect them in unique ways. So there'll be like basic things like an elevator, for example, that goes up and down, or a button or a pressure plate that you can press to activate certain things, or a door that opens, or some laser or something. And the idea is you'll be able to create those in real time and then connect them, and hopefully use that as like a way to create this really complicated, but also hopefully intuitive defense. And I'm hoping it can be done in real time. That's what I'm what I'm hoping is going to happen. We're not going to get there anywhere soon. That's kind of like stretch goal stuff. For this, just kind of want to play around with a whole bunch of different platforming things, because I haven't really done that in years. So we're gonna see what happens. This cube is gonna be my player, and we are not, I don't think, going to be using rigid bodies. So let's see. So I don't know the best way to do this. If we're doing physics, the problem with rigid bodies is they're unpredictable. So if we use a rigid body, I don't know how you're going to get around. So like a lot of this is sort of up in the air, and I kind of want to get the physics of movement down, and then just add like one element at a time, to make it more fun. And if the thing doesn't make it more fun, then we just don't add that thing. And so I don't really know where we'll end up, or where we're going, or how we're going to get there. I just kind of wanted, like, we're going to iterate towards that. And so the first thing to do is to figure out how we actually move our character. And once we know how to move the character, then we can do other things with that. So we have our player, and we need to figure out how to move them. So let's create this scripts directory, because every project starts with some scripts. And we're going to have a player. Because this is sort of like I don't know if a demo or an example or like a test, we're trying to figure out how to do a lot of this stuff. So I'm going to avoid a lot of the architectural things. So we've been playing with Zenject, for example. I'm not going to do that. We're also going to avoid like MCS and a lot of those other things, because a lot of what we want to get done or figure out is how these systems interact. And since I don't know that, we're not gonna design something that defines like how they interact together before we know how they interact, if that makes sense. So I'm thinking we're going to do something very similar with a kinematic body that we're going to move ourselves and then check for the different physics conditions. I don't know exactly how well that's going to go, but we'll see. So we're going to do player gravity controller. And this is not going to be anywhere near the final thing. That isn't really the goal here. What I'm hoping to do is have something that can just make the player fall, and we can actually use this to define things like the momentum system, and different like collision detection and things like that. But we can do that in a way that is only defined in a single dimension, and is a little bit easier to understand than when we have actual like inputs defining that. And so like the easiest is going to be like this dot. Why can't I type? There we go. Transform dot position minus equals vector 3 dot down or something like that. This is going to be too much, so we're going to multiply that by a time delta time, just so that it goes down eventually. We'll probably want these in a fixed update as well, and then make the controller does. I don't know if we're going to do like a grounding based check. There's a whole bunch of different systems that we could use to do this, and clicking play isn't going to do anything here. But I haven't explored this enough to actually know what makes the most sense. So I am imagining there's going to be some sort of rigid bodies or something, but we'll see. This is just moving down. This isn't actually doing anything. But what we should be able to do is actually turn this into some sort of collision detection. So we should be able to actually do like a physics 2D dot box overlap box. Theoretically, we can just plug this in. This probably isn't optimal in the slightest, but we should be able to maybe try this. Let me see. Rigid body always running? I don't know. So rigid bodies get simulated at different intervals depending on what you do. So we can talk about that a little bit. So if I were to add a 2D rigid body to this, I don't know. Yeah, there's a collision detection part of this. And in this, there's discrete and continuous. If you do a 3D rigid body, it's not going to like let me do that because we have 2D colliders on there. But if you do a 3D rigid body, there's actually 3 different ways of detecting collision. The difference between these is a discrete is going to check every frame. So every physics simulation, every step, there's going to be a check for your rigid body. If you set it to continuous, it's actually going to simulate it multiple times. And that's useful for like projectiles. So if something would go through a platform normally, like if you have something that's moving 10 units every frame, for example, like really fast, with a thin platform like this one, you would actually just go right through it. And that isn't exactly what you want. And so if you turn on continuous collision detection, you'll actually detect that, and you'll actually see that you hit something and it maybe shouldn't keep going. So that's one of the ways you can do that. But the thing with rigid bodies is they have their own physics. And so there's gravity here, there's a bunch of other things. We might be able to turn this on to a kinematic rigid body. And so the reason we might need a rigid body is there's 2 ways. If we can either use this overlap box, which is going to check if it's overlapping with any other physics objects and return the collider that it's hitting. And there's a way to get multiple objects if you're colliding with multiple things. But this would be a way to actually check if we're hitting something. But the problem with this is it doesn't have any optimizations, and you have to effectively write how to check for physics yourself, which doesn't really make a lot of sense. And things like horizontal or like slopes don't work with this. You can't really check with that. But if we do a kinematic rigid body, that is not going to have any actual physics simulation attached to it. It's just going to mark it as a rigid body. And collisions are only detected between something with a rigid body and something with a collider. So if we just have 2 colliders, they'll actually never hit. And we can show that. So there will be a void on collision 2D, something like this. And this is going to return a collider. And so we can log out our message here and say, I hit an object. And so this is going to say we hit something when we collide, and so we should hit something because we're actually moving down, so we'll hit that platform. But we shouldn't see that message because we don't have a rigid body, or we won't because I'm going to remove it. And so if we turn that off, this will move down, our compilers will go away, and we don't get any console messages. So nothing is going on there. Actually, yeah, sweep might work. We could use that. But if we go to our rigid body 2D and make it kinematic just so that it doesn't do a bunch of extra stuff, we can actually move this down and we should see a console message when we hit that. Or not. What did I do? Why didn't that work? On collision, enter 2D. There we go. I don't think I had the right function name. I'm pretty sure that's what's going on. And then that expects a collision. Okay, good. So that name's wrong, but we're not actually going to use that function, so I'm going to leave it. What should happen here is we should see our message now. So when we hit this object, we should have seen something. Why? Well, this is off to a good start. We're about to get into more complicated physics stuff, and I can't even make the basic stuff work. Okay, great. That's a good start. Why didn't that work? If I set this to dynamic, it should still work. Oh, I know why. What the heck? Why did we just go up? Okay, that's odd. Sorry, I'm confused why we're flying into the... Oh, I know what's going on. We attach that to our cube and not to our player. That's just wrong. Okay. There we go. We can get rid of that. Actually add our player. Not that. We need a 2D rigid body. There we go. This should make a lot more sense now. There we go. And then we get I hit an object when we fall onto it. And all of my other examples are wrong. But if we do a kinematic thing, we should also get that. We aren't moving because I didn't turn on the script. And now we're moving up because the vector 3... Oh, because we're subtracting a down vector. That's a positive up vector, actually. So we shouldn't do that. All right. So let's try this. And turn it on this time. And we'll fall and not get it. Okay. Interesting. So what I'm gathering from this is that collision events don't fire unless I'm doing this wrong. So we are doing the transform.position and moving it that way. That actually isn't going to trigger collisions. So we actually might need to do something like this. And grab our rigid body and get the component off of that. And so this is actually going to get our rigid body, and from that we should be able to do something like rigid body dot move, not add force, dot move to this new position. So we're going to do this dot transform dot position plus that extra bit and do something there. Even though this only expects a vector 3 or a vector 2, it should work because all of Unity's vectors actually inherit from one another. And okay, my IDE is broken. Okay, that's fine. This should work though, because if we use the transform, if we actually modify the transform, we aren't actually moving our object. But if we use the rigid body, we should have gotten something, but we didn't. Okay. See, but we did use the move position, and it still didn't work. Because I was thinking the same thing, but now we don't detect collisions at all. And so this might be a problem, because this might mean that we don't actually detect when two objects move into one another. And that doesn't seem like a good thing. And I'm not sure why this might be. But we need this to work, because otherwise we're never going to hit what we want. And that kind of matters, because otherwise, like, we'd have to like write everything from scratch, and I don't really want to do that. So we'll see. Player gravity controller, this should move it down. It goes right through it. That's fantastic. Great. Start awake. Never sleep. What if we do that? And then I move this to like 1. Does that fix it? No. Okay. So our kinematic object is behaving like a static one. That's not good. If we set this to, but it does have a box slider. Okay. Interesting. I actually don't know what's going on here. This should be working, so that's why I keep retrying it. But it's not working. Interesting. Okay. Clearly, I need to learn more about Unity physics, because I would have expected this to work. So we should enter that collision and actually do something. Unless, am I moving it in some other direction that I don't mean to? That's not gonna work. 2D. No, that looks about right. Okay. Yeah, I don't know. The platform shouldn't need a rigid body. We can try it. That might be what's required. Let's set that to static, because it's not going to move. If this works, I'm confused, but we'll see. No. Okay. So I guess we'll go through what my understanding of Unity's physics is, and then we'll try to figure out why it's wrong. So objects need a collider attached to them. In this case, we have 2 box colliders attached to each of these objects, and they're the same size as what we see drawn here. The other thing they need is one of them has to have a rigid body. And so the way Unity's physics system optimizes everything is when a rigid body moves, it does a collision check. And it only does it if the rigid body is awake. And so that's what this sleeping mode is. When the rigid body is awake, it will check nearby other colliders and see if it's intersecting any of those. And if it is, then it should call on collision enter 2D when it enters a new collision with some object. But that doesn't seem to be happening. We are not colliding unless we set it to dynamic. Enter collider 2. We are using 2D colliders. We have a box collider 2D and rigid body 2D. So everything should be 2D colliders. We're actually drawing cubes just because that's easier. But that's actually just a visual thing. So you can actually, Unity is a 3D engine, so you can render pretty much anything you want. In a 2D scene, you don't need to use sprites or anything. You can render full 3D objects if you want, and it will work because it's still a 3D engine. It's just using 2D physics. But there we go. That works if we set it to dynamic. But as soon as it moves to kinematic, it just goes right through. Okay, cool. I've never seen this happen before, so I'm not entirely sure where to go. We can use a trigger. Okay, let's try that. So if we do a player is trigger, we'll make the player can't be a trigger because we need to enter a trigger. Kinematic rigid body on the rectangle. Okay, let's try that. Player dynamic. We want that to be kinematic. There we go. And we'll see. This isn't really where I expected to get stuck, but I guess that's what happened. No, it just goes right through it. Okay, we're gonna test one other thing. I'm going to remove this and this and this and this. and we're going to add a box collider. So we're actually going to go back to 3D because I'm paranoid and see what happens. So we had a box collider and we had a rigid body. So now we're using full 3D stuff. We can turn off gravity and toggle kinematic stuff. And then we should be able to go in here, change these to rigid bodies. And this should just take a vector 3, so everything should still work. So I don't want to use the built-in force stuff from Unity. So part of the downside of that is we'll end up like hitting things. Okay, this doesn't work either. I guess that's good. It means it's not like because I know 2D physics, when it was initially released, had a bunch of weird things where it behaved slightly differently than normal physics. Oh, wait. I didn't update my message, so this won't work at all. There we go. So we update that, keep that kinematic, and we'll see what happens. It just goes right through. Okay, good. Good. So that means that it's not a 2D physics thing. It's still a fully 3D behavior as well. I just don't understand it clearly. So let's do not a rigid body. Let's add a box and another box and our rigid body. There we go. To forcing the velocity? I don't think so. So move position doesn't exist. One sec. So my understanding is if we use this, it will move the position by calculating the appropriate linear velocity required to move the rigid body. Nothing else is applied. So it's saying they should, because this feature allows a rigid body to be moved rapidly to a specific, any colliders attached to the rigid body will react as expected. They should produce collisions and or triggers. So that's why we're using that, but we're not getting those. What's their example look like? Fixed update. Oh. Does this fix it? That doesn't make a lot of sense if that works, but I'm curious if that would fix it. So let's try. That's set to dynamic, so that's gonna work anyway. We want this to be rigid body 2D. We have to revert all of those changes that I made earlier. Collision 2D, enter. There we go. All right. And I guess this is the price we pay for ignoring the best practices if this works. So all physics should, no, this didn't work either. Okay, well, running out of ideas. But that was a good one. I thought that could have worked. But we went right through it. All right, well, let's see. Collision 2D enter. Got it. This is not a trigger, and the player isn't a trigger. Huh. Okay. This is weird. So this should be triggering the updates. Edit physics settings in Unity. Is there something else going on? Contact pairs? Okay. I don't think I've ever used those before, but okay. I don't know how to navigate this new menu, so this might take a bit. Project settings, there we go. Physics 2D. So what is a contact pair? So we should, like, everything should collide with everything else. Okay, so Unity just updates the property inside of the fixed update. That is, I don't know if I actually like that, but that's interesting. I don't know what a fixed, like what a fixed or a delta time would be inside of a fixed update though. So I guess that makes some sense. Should be in physics. Contact pairs mode. Kinematics. Oh. Okay, is that in 2D as well? Or is that just a 3D thing? Is this like contact pairs? Let's turn them all on and see what happens. So my understanding is that's actually affecting like what rigid bodies can interact with other things. Okay, that didn't change anything. On collision, enter 2D. Is it enter? Oh, you might be right. I may be wrong there. I wasn't expecting this adventure to end so soon. Neither was I. No, okay. We're still going right through it. Let's see here. I'm clearly doing something like just slightly wrong, and I'm not entirely sure what. Collider 2D, on collision enter. Seen in here, they're just translating their object and getting rigid body dynamic. Okay, so they're using a dynamic object, so that's different. Interesting. At the moment, we're just trying to make. We have a cube that should fall and hit another cube, but it doesn't actually hit it. For whatever reason, it's falling right through it, and I'm not sure why. Like we can turn it. So if we turn on dynamic stuff, everything works exactly as we expect, and we should be able to set like gravity scale to 0, and something else. The problem with this is this means like everything else is modified too. So we can hit our object, and maybe the solution is just to freeze everything. So our object can't move and it can't be rotated, but then it literally doesn't move. So that's not what we want. But if we unfreeze these, then it can get other forces applied to it, like explosion forces and things. And I don't want that to happen. Like if things apply, I don't want it to follow normal physics, because normal physics is complicated and unpredictable, and I want this to be as predictable as possible. So if we use velocity, since it's a kinematic object, it won't actually move. So I can actually show that. But if we were to use a kinematic object and set the velocity, because a kinematic object says that we need to update all of these things ourselves, it's actually not going to detect it, which might be what's going on here. Nope, I haven't tried an Euler integration. I don't know what that is. So we'll figure it out. But velocity, like if we set this to vector3 dot down and multiply it by our time, fixed delta time, something like this, that will move it down a little bit. For settings pair, I set it to all of them, so they should all collide. Actually, well, we set the velocity, so the velocity should actually be modified, but the position doesn't actually change because it's a kinematic object for our player. The player won't actually move. Whereas if we were to set this to not kinematic, to like dynamic, and unfreeze it, it should start moving very slowly. So it is dropping just a little bit, and that's our velocity. But you get the idea. Yeah. I guess we don't need the delta time because that's a per second thing. But either way, if we use a a velocity, it's actually going to move it, but only in its dynamic state. If we try to use it in a kinematic object, it will be fixed, because a kinematic object is effectively declaring to Unity that I am going to handle my own physics. And that seems to be a problem, because if I've demonstrated anything here, it's that I don't know how to handle my own physics. So yeah, that's pretty much exactly what we want. We want physics calculations, so we want to know if we hit something, but we don't want to actually simulate the collisions. So the forces and things we don't want. I suppose like the alternative to this is physics 2D dot like box overlap box, or box cast, or circle cast. We could use things like this to actually simulate all of this, and maybe that's where we want to go, but that gets hard. And I don't know how in depth we want to make this. All right. So I guess let's try doing that. Let's see how difficult that gets. So if we do we need a raycast hit 2D like this, and we're actually going to need this vector here. So var movement is going to be that vector. That's going to be how much we're going to actually move. And so we can plug that in here. And this will be our hit object. And then if our raycast or physics 2D dot, let's use a box cast for now, but we can actually modify these. So if we do box cast, good call, fixed delta time. There should be a linter for that. Is there a linter for that? I haven't really explored Unity linters, but somebody should write a linter for that if they haven't. Maybe I should write a linter for that. So we're going to do a box cast here, which is going to, unlike a raycast, it's actually going to cast a box and move that box. And so we're going to have some sort of origin, which is going to be our current position. And the size is going to be a vector 2. I'm just going to plug in a normal, let's do vector 2.1. Just a basic placeholder thing. Angle, we're not going to plug in an angle. That might be handy for like running up things, but we probably won't use a box anyway. And then direction is going to be our movement. And so from that, we want a distance, which is going to be our movement dot length, the magnitude. And we want some sort of output of our hit 2D. I don't think that's an actual thing. Why does it start in a... Ew. Okay. Why... So it returns a list of results inside of... Okay, this is weird. So this is going to not work because it actually expects us to give it a list of things. So let's do a list of raycast hit. Actually, we don't want that. That's probably too much. We just need this. And oh, this API is not fun. Let's do something like this. That's a little bit gross. Let's also embiggen that a little bit so you all can see what I'm typing. So raycast hit, we're just going to assign that equal to the output of our box cast. I set it to all. So I would assume that would cover both. So kinematic, and kinematic static. But we don't have a rigid body on the other object. You should need a rigid body attached to every object in your scene. But I feel like that's a little bit more than we need. If you're interested in the setting, it is this one. Project settings, physics. This is going to be small, but it's enable all contact pairs. The very bottom one. But I don't know if we'll actually be using that. So this is going to do a whole bunch of fun stuff. Get our box cast. If our hit 2D is equal to null, then we didn't hit anything, and we can actually do our movement. So we're actually going to put the movement in there. Otherwise, we're going to print out that we hit something and not print it there. Well, so there will be dynamic walls in the sense that there'll be like moving platforms and things, but Unity's physics doesn't handle that well anyway, so we'd have to write our own for that regardless. Because otherwise what ends up happening is you just slide right off because the platform just moves out from underneath you, and I don't think we want that. So we should be good here. Something should happen. What? We hit the object immediately. That's not great. Let's turn off these constraints because they don't need to be there. And we'll make this kinematic again because that's gone so well. So what could go wrong? We hit an object immediately. Why? That doesn't make a lot of sense. So are we hitting ourselves? Can we hit ourselves? That doesn't seem good. If we were to turn off our box collider and try this again, do we still hit an object? Yes. So if there's two like types of moving things that you can kind of have. You can have kinematic objects, and those should be able to move, or you can have dynamic objects. The difference between those is going to be whether they simulate physics in Unity's engine or simulate physics themselves. And so what I'm trying to avoid is having Unity's physics get into this, just so that we have more control over that. And that hopefully will make it so we can actually like test this, and so we can actually control exactly how certain things should behave. So if I want hitting this specific object to jump you up 5 blocks or whatever our unit is, we can actually program that in. Whereas if we're using Unity's physics, we have to do our own calculations, but also factor in the impact of every other physics thing happening at that time. And that just gets complicated. Like if we have like if you think of Mario and you have like a turtle shell flying at you, that has a velocity. And if we were to just try to jump off of that, it would actually impart that velocity onto our player and like knock them back or something. And so part of the idea of having our own physics system is we can actually determine how all those interactions operate instead of relying on the actual like physics. Which is fine if you want like realistic physics, but if you don't, and you want some like more gamified physics, then this hopefully makes sense, but it doesn't really seem to be making a lot of sense. So let's see what we're hitting. Actually, we can do one better than that. Let's attach a... Well, that's not going to work. There we go. Let's see here. Where's Unity? There it is. So I'm going to add a Unity debugger here, and we should just be able to connect that to our Unity editor. And then when we run this, we should actually hit our breakpoint. So we should be able to see what we're hitting here and actually be able to inspect it. And so our hit 2D is hitting our player. So that's the problem. So we should be able to stop this. Maybe. And stop this. And figure out why, or just disable our player, I guess. So the downside is then our player doesn't actually have a collider. We're still hitting things. So let's reattach that. So physics materials are only going to handle things like friction and bounciness. They won't impact things like there's general physics rules, right? Like an object in motion is going to stay in motion unless something else acts against it, or two objects will have the same force. So like mass becomes a factor and things like that. And so you run into those kind of problems. What did we hit here? We shouldn't have hit our player. Oh, what? Okay, this is doing different things than I expected. I was expecting this to, like, so when we do a normal physics.raycast, what would end up happening is we would get a raycast hit object returned, but it's actually not returning that. The structure of this is different. And so there's actually a collider here, and that collider is null. So we didn't actually hit anything. There's nothing here, but it isn't, the returned object is not null. So this check that we're doing of hit 2D equals null, that's not right. And so that won't work. We actually need to do like collider is null. And that will say we didn't hit anything. Otherwise, if we did, we may want to actually move to that point. All right. I think we're actually making progress. This wasn't supposed to take stream lag. Are we dropping frames? I actually don't know. Let me check. It looks like it's healthy on my side. Now I need to figure out where I put that extra thing for monitoring this because I lost it. Status bar, there it is. No, it says we aren't dropping frames. It might be your connection. Okay. So yeah, I don't know if I can do anything about that. Oh, they're structs, so they can never be null. That's why this is the way that it is. Did we hit something? Yes. Oh, I never stopped this. That's not gonna work. All right, so that's done. We go back here, stop that, and get into here. We're gonna launch our debugger again, just because. We're gonna start this. We should see it fall, and then it should stop. There. And we don't get a message because we actually are at a breakpoint, but we are actually now hitting our object. So we effectively have physics that we wrote ourselves using this boxcast. All right. Have a good night. Let's see here. Hit 2D is going to hit certain things. We have our collider, and we have our point. Where is our current position? So our current position is like negative 0.779 or something. And the point that we actually hit is negative 1.3. So what we actually want is to be just above that, because we actually are hitting the object, but we aren't on the object yet. Effectively, what hitting this condition is saying is that if we were to make the full move, we would hit that. But we don't need to make the full move. We can actually make like partial movements. And so what we should be able to do, we can actually make this a little bit more obvious. So let's do a public float gravity amount, and we'll set that equal to like 10. And so what this is going to do is make us fall much faster. So we'll do this and multiply by our gravity amount. Right. Right. So kinematic objects should cause your collision events, but they should, because you're controlling the physics yourself, it should never actually do its thing, or cause it to stop, because it should just go right through it. What we're running into is like it wasn't even firing the collision events, and I'm not sure why. Um, kind of I don't know. I'll have to explore that some other time, but it doesn't really make a lot of sense, I feel like, to spend however much time we've spent on this just digging into that, because that doesn't seem like a very compelling doesn't seem like a very compelling like problem to spend so much time on. It seems more like some weird bug that I need to figure out. But we shouldn't be using triggers, I don't think. So we shouldn't be hit like causing any trigger events. We could make everything a trigger, but I don't know, that has other consequences, I guess. And I think with the way we're going right now, by actually doing these like casts, we should be able to capture most of what we need. And there may be some other things we need to do, but we may actually be able to turn this into something cool. So I think we'll try it and see what happens. And if it doesn't work, then we'll try something else. So here we're moving our object. We have our gravity amount now applied. And so what we should be able to do is stop this. There we go. And I'm going to leave that breakpoint there, but we're not going to use it for a bit. And so because we have that large gravity amount, what we should see is we should see our object be quite a bit further off the ground, like this. And so what we want to happen is we want this to actually touch the ground. And so we need this to figure out how to do that. In this case, that means finding the point that our box cast hit, which is going to be the center point of the box that collided. And then we actually want to position our object. So we want to do a rigid body.move position to our hit 2D. So this is going to be the first point we hit. And then we want to take it, I guess we have a box. So how do we do this? This will only work for vertical or horizontal movement. It won't work for anything else. So the difference between a box cast and a ray cast is this one is actually shooting a box out from our origin instead of a single ray. So a ray will just hit one point, but our player is not one point. They're actually like a box, or we'll probably end up using a sphere. But the idea is we actually want them to be operating as if they were that object and not a point. And so if we just use a point, like if we had a 1 pixel wide gap somewhere in our platform, if we're using a ray cast, you could actually fall through that. Whereas if we're using a box cast, you should just slide right across. Yeah, I think we might. There's going to be a lot of weird things that are going to come up because we're deciding to write our own physics from scratch. I'm not sure how awful that's going to turn, but we'll see. And depending on where it ends up, we'll tweak it. But I'm hoping what this allows us to do is actually put this under test. Whereas if we were using Unity's physics stuff, there is like some sort of physics. What's it? Physics.simulate. And you can theoretically use this in your tests to actually see where an object will go over X amount of steps. But that is more complicated, I guess. Whereas if we have something that's very deterministic, we can actually hopefully define a little bit more carefully what we actually mean. All right, so when we're moving a position, because this is gravity, we can actually do the hit collision or hit 2D, take the point, and actually move up by a vector 2 of 0 and 0.5, which is going to be half of whatever our point is. This only works when we're going straight down. Everything else is going to be wrong about this. But I think we're going to end up moving towards a sphere or a ball cast. So we shouldn't have that problem. But what I'm hoping that this will lead to is that we'll actually have our cube on the ground like that. And so this should always perfectly hit the ground. And there should never be like a gap or anything like that. And so that's sort of the advantage of this. I think this is even more accurate than like actually using Unity's physics. Well, I think they were doing pretty well with that as well. But we should hopefully get to the point where we actually hit this thing. And if we go underneath, we'll just fall right through. But here, even when we actually clip into the object, you can see it actually clips us back up because we're actually colliding with the point, because our cast is happening from the center of our cube and actually hitting somewhere there. So I guess that works. I don't know how this isn't going to handle slopes. I don't think. So if we, yeah, it's going to do something like that. Why is it going off to the side though? Okay, that's odd. Why did it do that? Is this because because we're hitting the point and actually moving? So this is actually causing our entire object to just fly off, because it's what ends up happening here is like if I rotate this a little bit more. That's awesome. So if we end up rotating this, what ends up happening is like we have a downward cast, and so we actually should hit some point, and then we'll hit that point and actually move to that point and move up half and then cast back down and then hit the corner, the top left corner, and then move back up above that point and then hit the top left corner and keep moving over to the side. And so this could be avoided with a raycast. Well, I don't know if that's a good idea or not. So if we used a raycast, we would always hit directly below us. Because we are having a box, we're actually not. So maybe the next solution here, to prevent us like jumping side to side, instead of doing this and using our old hit point, use an array of raycasts. So would the idea be to like have, how does that work? So the idea is you would raycast a whole bunch of them. Okay. Let's try that. I don't know how that's gonna go, but let's try that. And see where we end up. So if we want to do that, let's do our player gravity controller 2. Good name. So let's try that. What does that look like? We have our rigid body. We're still going to need that. And we're going to want this. Okay, and then that yeah, for detecting slopes, that makes a lot of sense. I was intending to use the normal. So we would actually, like from raycast, we will get a normal out of the object we hit. But I guess we could detect like stairs and things as well. Or even like if there's like small boxes or something. So that might actually work better. Cool, okay. Do you need them, so if we're doing raycast, do we need them only on the sides? Or would we need them like 3 on top too? I don't know if that's needed. We'll see. So we want to move down. So we have our rigid body, and now we need something to do raycasts. So if we are going to do an array of raycasts, what's the best way to do this? How should we so how can we store these in a way that makes sense? So we have like our cube here, and so let's make that a little bit bigger. So if we do like something like this, and just get sort of like a box, what we can end up doing is actually swapping some of these for points. And so 1, 2, 3, maybe, and then 4, 5, and 6, and 7. What? Okay. And then 7, 8, and 9. And so if we do that, do we need 5? Because we just need the outer shell, right? We don't need anything inside. And so if we're talking about this, do we need them to all face in specific directions? Or can that be dynamic? And so should they all go in the current velocity direction? So in this case, they would all go like down because we're falling down. Or would we have like one go off in a upward diagonal? I don't think that makes a lot of sense. But if they all go down, what might end up happening is if we have like some sort of downward platform, it would fall through the player instead of hit them. And so we need something else to determine if like the player was crushed, for example. You would need to actually have something else detect that, because this I don't think would detect that. And so if we're just going to do move direction, because I think that makes the most sense, then we can probably index this somehow. So if we want to get position 1, that's going to be equal to our current. So 1 is equal to our current transform position minus our size divided by 2. And then 2 is equal to our current transform position minus the size.y divided by 2. So this is the size.xy and so forth. And then this is minus the size.y plus the size.x over 2. And this might actually be inverted. So that would be up. So this position 3, sorry, I'm getting this wrong, is actually plus x and y. I don't know if this is helpful at all, but it helps me think. So we're going to add y there, and here we're going to add our y. Oh. And subtract our size dot y, or dot x over 2. Okay. The other alternative is we can actually just place these points arbitrarily on our object. Like we could just do a public transform or list, like transform array. Good point. I guess we can just use the downward arrays, like so the 3 downward points as a way of doing that. And so that will be transform vector 3 points. I think I want to store these as vector 3s. And so the idea here is they can actually be relative positions to our object. So public vector 3 of our ray cast origins, maybe. And so the idea here is we can actually go into our player. So if we did them like in like a clockwise orientation, how do we calculate what they are? I think that's the problem that I'm having, is I don't know how, like the idea of all of those variables there of like this was to figure out how we can actually give in a index in our array calculate where that point is in our object. Oh, you know, that's a good point. The object collider. So we should just be able to do dot collider. Where is it? That's not attached to the rigid body? Okay, weird. But we might be able to just do collider. Create a variable there. There we go. Get component of our box 2D collider. And then with this, we should have our bounds. And so this is some special Unity object that's going to have a whole bunch of fun things. Apparently it's also not defined. That's fun. I'm actually going to just restart that because that should fix this problem. But the bounds does actually have, I don't know if it's 2D or 3D, but bounds.x. Okay, we don't have anything there. Collider.bounds. There we go. So this is going to have a whole variety of different things. We have our size, we have our min and our max, and our extents. What is the min versus the max? Huh. Let's see here. Well, we can just go up this way. Whoa. What do you do? The maximal point of the box and the minimal point of the box? Okay. So I think we want to use the extents actually. So that will be the width and the height. And it's a box, so we should be good there. Okay. So it's top left and bottom right. Okay, that makes some sense. Maximum value for an axis. All right, interesting. I think we can turn that into something. I guess we need to figure out if we want to do a, well, that doesn't matter. Let's figure out if this actually works, rather than figure out like if we want to do a sphere or if we want to do a box. I think a box makes sense, but we'll see. So for this, we need our raycast origins equal to a new vector3 array of 3. I think that makes sense. And then we'll make that private for now. Origins.0 equals this transform position, not that, a new vector 2. We're going to make this out of vector 2s because we're working in 2D, and that just saves us a bit of extra work. So typically I've used spheres because in Unity they just go up like curves a lot easier, like slopes, for example. A sphere will just walk up that, and a cube will not. If you use Unity's default physics, a cube will hit it. Like if you just have like stairs or something, it will hit it. Whereas if you use a capsule or a sphere or something, it will actually work. So bottom right. Wait, min.x and min.y is bottom left, and max x and max y is bottom right. That doesn't sound right. Are you sure? Because then you'd only have the bottom 2 points. You wouldn't have the top at all. I would assume you'd want like the two opposite corners. But we can figure this out. All right. So that's not gonna work. Collider dot bounds dot min dot x and collider bounds min dot y. We can actually use an array constructor here. So we don't need to do all of this. We should just be able to plug it in like this. And so if we do that, we should be able to plug in 3 different objects here. And we probably don't even need that size bound anymore. This way we can just kind of plug math in and get values out. So we get our min x. We actually want this to be 0, I think. And then the min y. And so that should be in the center. And then our min x. We actually want this to be our max x because we want to move to the other side. And so the min y should be the bottom bit. And then min x will be one side and or max x will be the other side. It doesn't really matter because that doesn't actually factor into any of this. And then for this, we're going to do a void on draw gizmos. And let's do gizmos.color equals red. Color.red. There we go. And we actually want to use this. So for each our point in our, let's do raycast origins. There we go. And just draw these as rays. So gizmos.draw ray. And we can give it a from and a to. So this transform.position plus our point. And then this transform.position. It's just expecting a direction. So we can just give it vector3.down for now. And it doesn't like adding a vector3 and a vector2. So we're gonna have to slow things down just a bit. Point.x, point.y, and 0 for the y. And I guess that kind of works. And so we should see 3 points. Hopefully, if I did this right. First I have to attach it because that didn't work. So box collider, that's the wrong object. There we go. Gravity controller 2 can go in there. We're going to remove the other one for now. And so now we should see 3 rays get cast down. Or up, and we only see 1. So that's not right. Why is that happening? Transformed up position, adding our points. Let's try adding our debugger because I'm lost and this might help. All right. So where are these? That's not right. Why are they all the same? Okay. Let's get out of there. We'll continue. And let's restart this because I don't think that did what we thought it was going to do. We got different values. So min x is 0. Max x is also 0, I think. Yeah. So that's not going to work. That's going to get us other things. So the min and max are the same thing. And the size is 0? What? This doesn't seem right at all. Did I screw this up? Hold on. No, the size. Oh. I don't have a collider attached. It was disabled. All right. Let's try that. Does that make a little bit more sense? Now we don't see anything. Interesting. I may have this wrong as well. So gizmos should be on there. If we go into our game, gizmos can be on there as well. So let's play this. They're still all in the same spot. Oh. All right, there we go. This might get us something more interesting. They're either at the top or the bottom. It's hard to tell here. Because they were both 1 in that previous thing, I think we should probably throw a debugger on it and see what happens. But I think... What? We're not going to hit our breakpoint at all? Well, that doesn't make any sense. So either our vector3.down is going in the wrong direction. Pretty sure it's not. But I think those points are wrong. There's an easier way to test this. We can make this public, and that should throw it into our inspector. So we should be able to actually see it now. And so when we run this, I'm expecting that those y's are positive, and that's what's causing this weird thing. Yeah. So we're actually getting positive y's, and we don't want that. We actually want them to be negative. So instead of doing a min, we want this to be a max. Right? Either that or we want this to be inverted. I'm not entirely sure. But this should get us into the right spots. Now we're in the top, then they're going... No, now they're... Hold on. Yeah. They're not right at all. Okay. Min and min. So that's right. Let's save this. Stop that debugger because it isn't working. And restart it. I don't think either of these min or maxes is actually giving us the value that we want it to. So this y is still 0.5. And I believe the max is 1.5. So we're actually, like, the center is 1.0. Is this giving us world coordinates? Hold on. If I put that at 0, there we go, and then run this, does it give us the right answer? Yes. Okay. Well, that's annoying. So we need to subtract our current position from these bounds because they're in world space. That's annoying. Why? Okay. Grr. Well, I guess that we have to do it. So yeah, no, that doesn't feel right, does it? It seems weird, but I guess it kind of makes sense, right? Like you're trying to use this as a way to, like, typically see as something inside of this bounding box. But in our case, that's not what we care about. That might be right. Extents. What's inside of here? X and Y. So extents.x is going to do something else. There's an easy way to figure out what we're actually getting here. Inverse transform point. I mean, we can, if we really want, we can just multiply these by our object to world matrix or our world to object matrix, but I don't really want to do that because that just is going to make this really complicated, or at least add, like, extra work. And I feel like there's got to be a way to get these values without doing this. So extents does return the correct thing. It returns 0.5 and 0.5, which is half of the width of the size in either direction. So assuming we're at the center when we start this, we should be able to use that. So if we do extents.x, so this will be negative and this will be positive extents.x. And we want this at the bottom, so I'm going to subtract the y value. So this should give us 3 on the bottom. We do have everything for collision checks. You might be right. So what I was intending to do was to initialize all of this stuff in our start and then work on it from there. If we wanted, we could put this in our fixed update, and actually just use it there and then regenerate this array every frame. I had hoped to kind of save on having to reallocate every frame. And so we could actually like store where the positions are and use those local positions and just calculate it that way. I guess we don't really need to worry too much about the optimization right now, but that was sort of why I was looking for local positions. Maybe that doesn't make sense, but yeah. Oh, that's a good point. Yeah, things might change. I actually hadn't really thought of that. So we may want to, what the heck? Locked out of Unity. Okay. Can we fix it by starting and turning off our debugger? Nope. All right, Unity's dead. Cool. We'll kill that and come back to it. So I think you might actually be right. Because if we do it here, if anything does change, we run into the issue of having to recalculate all of this anyway. And so it might make sense to start off with to actually keep this as the min and as we had it. So this will be our world space raycast origins. Something like this. So fixed update is this. And then we need our collider saved in memory so we can reference it. So private that. There we go. Unity doesn't like me today. This is weird. It's totally frozen. I think I broke it when I tried to quit, but I'm not entirely sure. That's new. Unity isn't running. All right, well, let's just kill everything with Unity in the name. Nope, that didn't work. Okay, well, according to my machine, Unity isn't running, but it definitely is. So this is going great. Seems like there's a whole bunch of things. There we go. Just go and end a bunch of tasks that shouldn't be there. What else is going on? I don't know. But we can't close Unity, so that's interesting. And we version of Unity is 2019.1, which should probably update. That's 2 versions behind now. Yeah, I think you're right with the like character controllers spending a little bit of extra time, or at least making it feel good. What the heck? It's totally dead. There we go. What? There we go. Cool. Fixed it. All right. Well, that was an adventure. I guess we're living up to the title of this stream, having a whole bunch of adventures. Unfortunately, they're more the adventures of misfortune than fortune. But yeah, we'll see. Eventually, we'll start rolling better than like a natural one. So, all right. I think what ended up breaking Unity was our debugger didn't detach entirely, so that you could see there was like a thread abort error. And so I think what ended up happening is our debugger detached itself, but had still locked Unity, and so you can't select Unity because we're doing all this. I suppose, yeah, it's sort of debugging. And I had done, like, I had hoped to work on this rather than the Minecraft clone project, just because that one is going to probably have a lot more debugging stuff as well. Because the next step is figuring out how little we need to actually copy from the world in order to actually be able to clone the world. And what values we can change just by ourselves without breaking everything. And then figuring out how our world can work with that. But anyway, I think we're in a good spot. Well, we're compiling, so that's good. Let's do this. Did I lose my world? I totally did, didn't I? Yep. All right, cool. Let's make a new world. We'll put our cube in. I should actually save it this time. That would be smart so that we don't have to do this again. Box collider, there's that. That's our floor. And then we'll add our player. Throw a rigid body on it. And do we even, because we're moving things, we may not actually need this to be a rigid body at all. There might be some advantages still, so I'll keep it, but I don't know if that's actually required. And then we need our gravity controller too. Cool. All right. So let's move our player up a bit and stretch this one a little bit. Has it really been an hour and a half and we've created a floor? Yep. All right. Cool. So it's going slightly better than the video I tried to record previously. Oh, and then our gizmos are being drawn by using our transform position. So we're actually adding our transform twice, so we can take that off, and we should be able to get something. Minecraft and Unity? That sounds like work. We've done voxels in the past, and they were much easier than this. Like voxels aren't that hard, and then that once you get that, you're pretty much part of the way to getting Minecraft, right? And so I don't know. Minecraft doesn't seem like it's that hard of a game. I think a lot of the complexity of Minecraft comes from just the variety of things you can do in it. Because like the world initially was just like creative place blocks that have different textures, and even that is all just one shader and one texture, and it's just looking up different UVs of that same texture. But then you start adding extra stuff and it gets harder. All right. Good news is our stuff is in the right spot. So how do we want to do this? I think we want each of these to have some sort of velocity. So we're going to have our float velocity equal to time dot fixed delta time. And we want this to be our public float of our gravity amount, and set that equal to say 10. So effectively doing what we had in our original gravity controller, just kind of doing that here. And multiplying those two together so we have some sort of amount we're going to fall. And then I think what we want is we want to do a raycast for each of these. So for each var origin in our raycast origins. Okay, so it's a little bit more than just like the voxel stuff. That could be cool. Because I think like the chunking is hard. Also, the generation of the maps is hard. That part's interesting, but I haven't really explored a lot of those. Store rays in a class list to store if they hit. We'll probably be refactoring a lot of this. Right now, I kind of want to get like separate objects into different parts, and then we can kind of combine the parts that make sense. So like right now we just have like raycast origins. We're probably going to have some like collection of raycast hits, which is going to be this, which is going to be raycast hit 2D and some array here. That's going to have a size equal to our raycast origins. The downside of this is that it means we can't use this for each loop like this. We need to do a for int I equals 0 and sort of iterate over it the classic way, because we're actually going to need the index. So something like this instead of what we have on the left or on the right there. Dot length. There we go. Yeah, I think like raycasting almost is easier to understand, I think, than a lot of just like standard rendering. Like what we usually use as like a way to render is not very straightforward. It doesn't make a lot of sense when you first look at it, whereas like raycasting is relatively understandable. Even like it looks intimidating, but actually like doing the first raycast is not that difficult. All right. What are we doing here? For all of these, we want to iterate over this, and we want to store the raycast hit into that array. So we want to do raycast hits of I and store that into our raycast origins. Not store that into, what am I talking about? We want to do a raycast based on that. So physics2d.raycast. And I think for this, we do actually want to use raycasts, because if we were using something else, we would be beyond the size of our own object. So we're going to do a raycast of from our current position, so the raycast origin of I. And then the direction is going to be our down vector. So vector3 dot down times our raycast hit, or our velocity. That's the direction. We actually need a separate velocity. So velocity can go in there. And so that should actually assign out our raycast hits to each of these. I hope they cast straight and true. This has not gone as I had intended. The last two like videos I've tried to record have also gone in this general direction. Mostly because I've like overlooked a massive part of something and then gotten halfway through recording and be like, oh, what about all of this? And realized that I hadn't even bothered to consider that before clicking record. And then an hour later, we realized, oh, that didn't really work. So I'm trying to get better at that, but at the same time, sometimes things just don't go the way you want. So raycast hits, we've now stored those in this position. And so I think we want to bias towards the shortest distance. What is a raycast command? Oh, okay. We'll have to explore those sometime. I'm not super familiar with those. But that sounds cool if you can like batch a whole bunch of raycasts. Because I think with the way we have this set up, we're going to end up with like 8 or more raycasts. Multi-threaded raycasts. Okay, interesting. I didn't even know that was a multi-threaded physics was a thing in Unity. At least not until the Havoc stuff gets in, whenever that's happening. All right. So now that we have points, we've effectively figured out where we've hit. We need to actually do something with that. So we have our raycast hits. This is going to be harder than I thought, because we actually need to translate our object based off of what ends up happening. So like just kind of thinking off the top of my head, but if there is, let's include link here. There we go. So if there is any, or if all, sorry, if all of our raycast hits, hit.collider is null. So if all of the colliders are null, we didn't hit anything. So this is like the default case of like we didn't. Okay. Yeah. I try to kind of capture a lot of like the puzzling things out, but at least in like the last video I did, I was trying to tessellate with the snow shader that we had released like a week or so ago. I was trying to tessellate and extrude the snow so it looked like it actually accumulated and grew up off the rock. It turns out that's actually not not as easy as it like sounded to me, because I was thinking like we can just take this and then take the snow direction and just move it up. It doesn't actually work like that. There's a whole bunch of other things that have to happen, and so we have to like do normal map calculations inside of our vertex shader. And I hadn't really thought about doing vertex calculations inside of the or normal calculations in the vertex shader. That ended up just derailing things, and it's there's just a lot of like googling things and trying to figure out what's going on. But yeah, anyway, this we want to actually move our rigid body, right? So we can just do rigid body.move position and actually just move our rigid body by however much. So we're actually going to just move it by our velocity times the direction we're going. So time.delta time. Fixed delta time. And so that should move us. We need a current position. So we'll do something like this. And we want some direction. So vector 3 dot down times all of this. Yeah, I'm starting to think like we're going to hit a lot of edge cases here, but I also just kind of like the biggest thing for me in a platformer is does movement feel good? And so you end up with games with like Celeste, for example, or Mario, and movement feels good. Whereas you can end up with games like I don't know, Assassin's Creed kind of comes to mind as like one of those games that looks and feels fine, but at the same time like the actual platforming just isn't quite right for whatever reason and just feels off. And so things like that become hard to tweak if you're using somebody else's asset because it's usually very ingrained. The best one I've found actually is there's a third party character controller for 3D games, and the entire thing is component based. And so every action that the controller can do is actually a component of that controller. And so if you want to do like rolling or jumping or something, you just add that component. And that was actually really easy to use and really easy to extend. But a lot of the other ones are like built for a specific purpose. And I found that kind of difficult. All right. Move position. This should move us if we don't hit anything. Otherwise, we'll hit something and do something else. So what I'm hoping will happen here is our cube should fall a little bit and then stop. And hopefully it will hover in the air somewhere above the ground or not move at all. Great. Like jump equals new jumps. I'm not like, so here we're not really working on any particular architecture. There, we don't really have like a lot of things. There was a stream that we did like 6 months ago where we were also exploring different character controller things. And we were looking a lot at that kind of architecture of how to handle like input events and handle those kind of things. Here, what I'm trying to focus on is more how do we handle actual movement, and then figure out that and actually probably destroy all of this and turn that into some sort of pattern that actually makes sense. Velocity, gravity amount. Maybe it's too big. I guess we can figure it out by just moving it much higher. No, it's still hitting something. I'm not sure what. We can put a breakpoint there. And we should hit that. So our hit collider is equal to null. If all of them are null, then we're good. Are they? Oh, no, we're hitting our player again. So we can solve that by turning our player off. That's easy enough. Ideally, what I would like to do is actually use a mask to avoid our player hitting our own player. But for now, we can actually just not deal with that. And just turn it off. Done. Right. That's not going to work because everything's based off the collider. I forgot about that. Interesting that they didn't all end up one on top of the other. But this is just going to be slower because it's all based on this gravity amount. And then eventually it will stop. And now it's in the object. That's not what we want. And it's actually still falling. Oh, because I turned the box collider off. That's what happened. So all of the points are actually centered inside of our object. So let's do this. We'll set the box collider like that. And if we make it a trigger, it'll still be hit by raycast, right? So this isn't going to change anything. Yeah. So that means we need a mask. What's the best way to do this? Does that work? No? Okay, fine. We're gonna have to go and do a raycast 2D. Or physics 2D, that's what we want. So I think we can use a layer mask, but I think this character controller is something we're going to probably end up using for more than just our player. We might end up using this for every entity inside of our scene. And so if we try to layer mask out every object in our scene, we're going to run out of layers. And so I'm hoping there's a way where we can just ignore a specific collider. but I don't actually know if that's possible because I've never really tried that. And I don't know if this is a good idea. It doesn't really feel like a good idea. We're going to try it. Layer mask, distance, yeah. The min depth. That might work, but that could cause other issues. So let's avoid that. Hit collider. We're just gonna hit ourselves. So let's use a layer mask. Right. So all of this, let's add a public layer mask. Though I guess this could work because we could actually just have our enemies not run into one another or something like that. That might work. So mask equals something. We're just going to leave that blank and plug that in down here. And so it accepts an int here, but we actually used a layer mask object, which I believe is a enum. Can't inspect it, so we're not going to. But that will actually give us the matrix that we can actually modify. And so when we want to mess with this mask, we can actually just work from here. In this case, we have it set to mask nothing. I forget the direction this works. But we want our player as its own thing. We're going to put the player on the player layer, and then we are going to mask out. I think we want to do it this way, so it will mask. It will hit everything except the player. So there was a min distance for the raise. I'm somewhat concerned that if we start using that min distance, what's going to happen is we're going to get really close to our platform and actually just sink through it. And I don't want that to happen. And short of figuring that out, we're going to ignore it for now. So I think what we want is we want to do small problems at a time. And right now this problem is very big. And so we need to make it as small as possible so that we can start like finding actual places where we can make progress. Because otherwise we're going to just run into this thing where we're like, we're going to make a platform controller that can do everything. It can go on moving platforms and spinning platforms and do all of this other stuff. And doing that from the start is going to be hard. And so if we can avoid trying to do all of that from the start, I think we'll end up in a place that is actually working instead of building this massive thing that doesn't really work yet. And so we have falling now. Our player can actually fall. And so we fall pretty slowly though. Oh. That's because we're multiplying by our delta time twice. So this might make a little bit more sense. We should fall much faster now. There we go. Better. Okay. That's fixed now. And so what we actually want is to actually hit the ground. Does that work of moving it inside? Because I was under the impression that arrays that started on the inside shouldn't collide, but if we're moving away from our object, I would expect we wouldn't hit it. Maybe it's like a precision thing and we are just like on the very edge and that's causing us to hit it. So if we do move it in, would that help? That might help. So the way raycasts typically work is they only hit things that they enter. They don't hit things they leave. And so if you have like a spaceship and it's just a giant sphere or something and you want to raycast out of it, if you raycast from the center of that sphere, you won't hit the sphere on the way out. But if you hit some other sphere, you'll hit that. And so that kind of prevents you from doing anything bad. That doesn't seem to happen here. And I'm not sure why. I think it's because we're going right to the edge and that's causing everything to be wrong. So I think Jason's on point there. But I don't know what a good solution is, short of just adding like some slight padding, which I suppose we could do here, right? So if we do plus 0.1 f, I'm just going to make this up real quick just to see if this fixes and we don't need the layer mask. So I'm going to pull the mask off for now. And then that's in the center. And so for this, we're just going to subtract 1 or add 0.1 f. And so this should just give us a more than a lot of padding. We should actually fall like into things now, but that should be fine. Oh, you can actually just oh, that makes sense. But I think we're still like, I think the raycast still hits. I could be wrong. Because this one seems to say like anything that it hits is going to be returned. Yeah, I think this, like this line here, will detect colliders at the start of the ray. In this case, the ray starts inside the collider and doesn't intersect the collider's surface. This means the collision normal can't be calculated, in which case the return collision normal is set to the inverse of the ray vector being tested. Yeah, I don't know if we can do skinning in this. I don't think that's going to work. For now, I think we'll stick to the mask, and we will explore this some other time. Because I don't really know. I don't really know where to take that, unfortunately. And I think we can explore it a little bit more. But yeah. So this should get us back to it dropping like that. And we'll hit. And then what we need is some sort of modification. So instead of moving like this, we need to be able to detect how to get to the bottom. So this will move us if we don't collide with anything. Otherwise, if we did hit something, is this going to end up as a platformer tutorial? I don't think you want this as a tutorial. Like I don't. Maybe after we like figure out something a little bit better. But right now, like this is me like poking at this and trying to understand like how to make all of this work. And it's not something that I'm super familiar with. So we'll see. If I can get something that I'm really happy with, that will probably end up in like a smaller segment. But we've spent like 2 hours and we barely have falling. If that gives you some perspective. Like this platforming is not a simple thing. And so I feel this is why I kind of feel like it's a stream project, if that makes sense. There's probably certain parts of this though that we can cut into videos, or even parts of this stream itself could end up as videos. I don't know exactly. So what I want to do here is actually find the shortest raycast hit, because we now know that we had one that we hit. So if we do raycast hits, and do first or sort order by, there we go. So if we do the hits and we order them by, this is not a good idea, but we order them by the distance. what we can actually do with this. Oh, does he have a full tutorial on this, like a full series? I didn't even know that. Huh. I should probably read up on that because that sounds really handy. But if we order this by our distance hit, this should be in ascending order. So the first thing should be the one with the shortest distance. And so that will be the amount that we can actually move in this direction. And so if we take the first thing off of there, bar shortest raycast is going to be equal to this. And then we should be able to move by whatever that shortest length is. Oh, cool. So it does slopes and platforms and everything. Oh, okay. That's handy. Yeah. Hopefully we're like 5 minutes from slopes. Maybe. We don't have movement yet, so that's optimistic. But shortest raycast. There we go. And so if we take the shortest raycast, what I'm hoping we can do is use that as the amount of distance we're going to move. And so we do something like this: rigid body move position our transform plus our vector 3.down, and just take the shortest raycast and do a distance. At this point, I'm going to leave the order by here. I don't think we want to keep that. Okay, cool. So that works. So there's a few problems with this. We're using an order by, which is actually going to do a sort. We're sorting 3 things, so it doesn't really matter because it's pretty small. But we don't actually need to sort this. We can just do a min of the hit distance. And so this actually prevents us from having to do that sort. And so we should just get out the distance here. And so the shortest raycast distance is the result here. And so the advantage of this is instead of doing a sort, which is going to be like O of n or O of n squared or something like that, we're actually just going to iterate over this from front to back and just overwrite the smallest thing. And so hopefully that gives us a better result, or it gives us a faster result. And then this way we can actually simulate our cube. So the cube should still fall and hit the ground. And if I actually rotate this now, ooh, that's not what we want. There we go. If we rotate this, we should hit a corner and stop. There's still a little bit of a gap there. I'm not sure where that's coming from, but we kind of have a falling cube. So I think that's progress. And then really to get this to actually move in other directions, we just need to remove this vector 3.down and replace it with some other magnitude or some other velocity. And so that should actually get our player moving. The downside is we still, like if this starts rotating, it doesn't look great. But I'm actually, whoa, there we go. I think that turned out all right. Raycast origins. Why is it levitating? That's the biggest question. Because it shouldn't be. Like, so why is our, what that must mean is that our distance is equal to 0? But I don't think it should be. Let's explore a little bit more. Unless I'm thinking of this wrong. But we'll see. So if it was from 2015, that would have been like right after like Unity 2D stuff was released, like a year or two after Unity 2D stuff. And I don't know how much that stuff has changed since it was released. I don't think it's changed that much. But maybe I'm wrong. Let's see here. This is not a good way to do this. Actually, no, we would have already hit the ground, so we're good. So what's going on here? Why is the distance equal to 0? So if we step over this, what? There we go. Our shortest distance is still 0. Raycast hits. Distance is small? Oh. That's what's happening. So we're hitting 1, but we're not filtering out the ones that didn't hit anything. And so those ones that haven't hit anything yet are actually going to have a distance of 0 because they're not initialized yet. So we want to where in here where hit.collider is equal to null. Hit. Something like this. So we're going to pass the hit in, say where the hit collider is equal to is not null, sorry. Then we want to take the minimum of those and return the distance there. And so this should always return some value because otherwise we're going to get 0 or we're going to not have entered there because this wouldn't have happened. So this should always be happening if we want it to. And then move position, that should work. And so hopefully, yeah, cool. It already corrected itself, so we moved down that extra little bit. But if we actually run this now, we should fall correctly. And then if we start rotating this a little bit more, we'll actually stay connected to this. We won't go back up because we don't have anything above this to actually say there you need to move in a negative direction. If we add points to the top, I think that should cover that case as well. But we just haven't gotten there. But I think that's cool. That gives us a way to kind of do the falling and the actual platforming bit, which I think is probably the hardest part of this whole thing. Moving horizontally shouldn't be too difficult, especially since most of what I have in mind is going to be flat things. I don't think we're going to want a lot of like slopes initially. So yay. It only took us 2 hours. I had estimated like 45 minutes, so we're off by like a factor of 2.5, but yeah, it happens, I guess. Right. So I think the next thing is actual movement, like actually being able to move. Yeah, pretty much standard. Normally I'm pretty good at getting like an estimate for these kind of projects, but that's usually because I have them drawn out. So yeah, I think this works. I guess there's a few people here, so if you want to see us switch to the MC clone stuff, we can do that, or we can keep tinkering at this for a little bit longer and try to get more movement stuff working. But this is probably a good place to cut here if we want to and move on to some other project. Otherwise, keep going with platforming. All right. Yeah. If nobody else has other feelings, we can do more platforming stuff. But so when we do when I do estimates at work, typically like we have a spreadsheet of like what were our estimates for the week and how close do we actually come, and we would keep like a list of those every week and try to understand like how far off we were each time. And since it was estimated by our team, we were actually kind of correcting each other. And so like if one person had like underestimated these specific problems and somebody overestimated these specific problems and so forth, you could actually kind of correct those a little bit. And you had like a little bit of a better idea of like how much time you actually had. Because typically like I see when it comes to estimates, I see like 2 different times. Like somebody who estimates like very long, because it's like lots of unknowns or don't really know what's going on. But then like either you finish it a month early or whatever, or the project never gets done because it turns out it's just much bigger and nobody really knew what the scope of it really was. Or the other thing is like you estimate like very short, and then you're trying to like rush and deliver and crunch to get it all done. And neither of those really aren't great. So I don't know. Estimation is weird. It's it's not something I'm very good at. Does this work? Sorry, I'm curious. No. Okay, that doesn't work. Our points are in the wrong spot. So if our cube rotates, everything breaks. That's good to know. I suppose, yeah, it really depends on what you're doing. For us, we were all working on like a microservice thing. And so we kind of had a good idea of like, here's how much ops work we're going to have to do. Here's how much infrastructure work we're going to have to do to get this whole thing stood up. Here's how much work we're going to have to do to test this, and so forth. And it was pretty much like we could print that process. If it isn't like that, if your work is always different, it's not going to be very straightforward, and that probably isn't very helpful. Yeah, I don't know. All right. So I said we were going to do more platforming stuff, but I don't actually know what I want to do next. So we have a player who falls. We could either make it so when we rotate this, they go back up. I don't think I want to do that. The other thing is we could make it so that when the platform moves side to side, it works. And the third is we could do velocity on the player. I think the velocity is the most interesting problem. I'm pretty sure. So we'll see. Does that make sense? Yeah, let's do velocity stuff. Yeah. All right, I'm going to delete this other. I'm not going to delete it. I am going to open this up. We're in our assets folder, so let's do a git init. And let's commit our assets folder. Whoa. There are 2,000 changes. Git commit or git add. Let's add our assets folder. Cool. And so that, yes. So that stages everything. That should be good. We can commit our metadata and then our player controllers. Add player gravity controllers. And this is just saving a working checkpoint effectively. So we have somewhere to go back to. And so this way we can actually start deleting things without worrying about losing our code. Because now it's committed. We actually have a record of it. And so we can remove this. And I could rename that player gravity controller, but this doesn't really matter here. Doing this more as like a best practice type thing. But what we actually want is we want to do a git move of our assets, scripts, player gravity controller to our assets, scripts, player, and we want to move that to a player gravity controller. Let's call this the player movement controller. Apparently it's not move. MV? Yeah. Okay. And so what that did is actually move things, but I used git to do it. And so the advantage of doing that is it preserves history. And so when you actually if we were to go and look at this in like GitHub or something like that, the previous commit that I did to actually add this to the project should still be there. And so the advantage is that now if I ever want to go back to that player gravity controller 2, I can still do that without having to go and look up that deleted file. That's the wrong thing. And so just sort of a nice thing, if you were to like rename the file on your file system, Git isn't going to know what happened. It's going to think that there is some new thing. And so that's that. But I guess that's like the most basic way we can save this or preserve this. Like you can see Visual Studio Code thinks we deleted that previous thing, but it exists right here. So yeah, there we go. Yeah, I think that's most of what we needed to get done. This is now going to handle our movement instead of the gravity, just because that makes a lot more sense. For now, I'm going to just keep it as the 3 bottom points. I think that makes the most sense. We're going to get into a lot of weird issues with everything else if I start adding extra bits to this. But yeah. Manually backing up to a external drive. That's not the worst thing I've seen, but I'm happy to chat about how to do other things. So like part of the idea here of using Git is that you can actually keep your change lists and actually revert back. And so if I wanted to see like the history, you can actually see I have an extension in Visual Studio Code that's actually going to show me the history of I committed 3 minutes ago, add player gravity controllers to this project. And so if you have like multiple people working on it, you can actually see what's going on in your project. Or if something breaks and you don't know what, you can actually roll back to a previous change that actually worked, which is hard to do if you have like manual copies. Plus, Git is a distributed file system, which means that I can push this up to GitHub and it will just work, or somebody else can pull it off of my computer or whatever. And so there's a lot of other advantages. And because it's all distributed, this history preservation is still all local to my machine. There's no server doing all of this. This is all handled by my local thing. The only thing that it did add was a Git file in here. So it's just a .git file that has a bunch of extra metadata, and that's pretty much it. And it's not even that big. So it does get, with Unity projects, Git can be a little bit of a hassle because it's Git and it's designed for small like code files, not large assets. So like audio or movies or things like that don't necessarily work great. But for most of what we do here, it's fine. So yeah, that's my Git pitch. If you want to talk more about that, you should message me and we can chat, because that's that's sort of the thing that I do a lot. So yeah, binary stuff, it's not so great. You'll see in games, I see a lot of people biased towards like Perforce. And the advantage of Perforce over Git is that it can do binary diffs. So you can actually see, like, if somebody modifies an image, it can actually say these 5 pixels in this pixel art for your player were modified at 5 days ago or something. And here's who did it. Git can't really do that. It can say this file was modified and here's all the bits that changed. But it's only going to know the bits. It's not going to understand the file for you. You can get extensions that will do that, but that's extra. I have a like change tree somewhere, but I'm not going to go too deep into that. I guess here is what the current thing looks like. There's a whole bunch of extra stuff. I'm just using GitLens for this, which is it's a free extension for Visual Studio Code. So anyway, that's backups out of the way. Let's do velocity stuff. So we have been using a vector to kind of say, let's go down by this amount. Let's actually store that as something other than a down vector. So this will be our velocity. I think that makes sense. It's actually git lens. I can actually, hold on. Let me. grab the extension for you. So there's the link to their GitHub. It's pretty much just an extension that adds a whole bunch of extra stuff for working with Git into Visual Studio Code. I would recommend like just picking up like the bare basics of Git if you've never used it before. It's a little bit confusing at first. It's not straightforward. So like the two commands that I used there were git add and git commit. I didn't actually click or type git commit. Visual Studio Code did that for me, but git add is going to mark files to add to your source control, and then git commit is actually going to commit those into your source control. There's a bunch of other things. I actually have 2 videos that kind of cover a little bit about that, and so you might check those out. Otherwise, you could join our Discord, I think, and we can chat about that later. But we'll see. All right. So our velocity is going to be equal to vector3.down. I think that makes the most sense. Yeah. So velocity vector3.down. That's not what we want. Ooh. Using velocity in a different place. That's fun. We actually don't want that. We want velocity dot magnitude right there. We can actually just get rid of this. Times our time dot fixed delta time. Movement length. Sure, that'll work. And so instead of the gravity amount, we're going to multiply by our velocity. And this will allow us to kind of modify things. Movement length. We have our mask. Everything should be good. We need to change this in a bunch of other places as well. So we have our velocity. Velocity times our movement length. And we have our down again. Velocity dot normalized. So we need to normalize this in this final situation because we're actually moving by a fixed distance. And so we don't want to exceed that distance, whatever it is. And I think that's everything. Yeah, the only other thing that I want to add is we should do a velocity here instead of the vector3.down when we're drawing our gizmos. And that should hopefully give us some extra stuff. All right, I broke it. Our script is gone. What'd I break? Oh, so I renamed the object and that made Unity lose the reference to it. So we're gonna fix all of that. There we go. Our velocity is private. That shouldn't be private. Let's make this public. So we're not applying gravity anymore, but we do have the velocity set to down. So it should still be applied. So it should still move down. It'll be a little bit slower, but that's fine. And so we hit the ground, but I should be able to set this to, say, 1. And I would expect us to go up. We're on the ground, though. And so because we don't have that skin, we're actually just going to hit everything. So right now, what's going to happen is we're actually going to hit this cube below us, unless I move up a little bit. And that's not really what we want. But we can move side to side like this. That doesn't seem right. Or go down. That really doesn't seem right. Why is that like that? Point X, point Y. Oh, I didn't design this to go side to side. This transform dot position dot x. There we go. And so that should be the center now, and we should avoid some of those other problems. We probably want a skin though. We had avoided that, but without it, we're actually going to run into some issues. So collider.bounds, and I think it was encapsulate? No. Expand. So we want to expand this bounds by some negative amount. And we're going to expand it by 0.05 f, some small amount. What's going on here? Oh, that doesn't return anything. That's annoying. Okay. Is there a way to copy this? Because otherwise what's going to happen is we're going to actually modify our collider. And I don't want to do that. Because that's going to cause a whole bunch of other issues, because it's going to effectively cause our collider to itself to shrink over time. And we don't really want that. I don't see a good way to shrink that, so we're just going to go back to the old. This is going to be a plus 0.1 f, I guess, and we will pretend, I guess. Since these are mins, we're going to add 0.1, so that should move them up. This one needs to go to the right. This one doesn't need to move. And then this needs to go to the left. And so we should get points inside of our cube now, hopefully. I think bounds is a struct. Now we're inside of our object, so okay, I get it. Can we? So if we do collider.bounds.expand, and we expand it by like negative 0.05, something like this. Make that a float. I have no idea if this is a struct or not. We're gonna find out, because if it is, we're gonna see some really interesting stuff happen. Oh, okay, I get it. That makes sense, because it's a, okay. So I should talk a little bit about this, because otherwise it's going to be confusing. But structs are value types. And so what's happening here, if this is a struct, is we are copying the value of the original bounds into this new bounds variable. And so that's going to be stored there. And because it's a value type, that means that it is a brand new value. It's similar to like doing a float. So float 1 or something. Those are values. And so whenever we reference a value type, we get a new copy of that value. If we're talking about reference types like classes, that's actually going to be a pointer back to that reference. And so if this bounds is a class, we're going to point back to it. And so modifications to any reference is actually going to cause it to affect the original. Which means that this will shrink our actual collider. But if it's a struct, because we're copying values, this will only modify the value that we're currently working on. That's the idea. Which means we can drop all of this collider stuff like so. This is going to break some of our other math, because now we should actually fall into an object. Okay, and so we actually, it's hard to see here, but we actually did fall into our collider. Like you can see here, we have just like 0.05 or whatever our skin is, that's fallen into our object. So we need to modify that. The other thing I want to test is if we can get rid of this mask now. No. Okay. Well, that's annoying. um, so we still need the mask. For whatever reason, that doesn't seem to work in Unity. I'm not sure why, or it doesn't seem to work in 2D. So the other thing that we need to test is this. We have our hit distance. Our shortest raycast distance is going to eventually hit something. So we want to add a movement length plus our skin size, which we don't have right now. So we want to add that in. Just gonna throw a bunch of values at this, and we'll make it up. We'll make it work later. So now we have a skin size that's just sort of there to give us a value to use. We're adding that onto our raycast length, and so the reason for doing that is it means that we can still keep this hit nothing unmodified, so that doesn't need to change. But we do need to change this. This else is going to actually collide with things. And so the shortest ray distance is actually not this value. It's actually this hit distance plus some value. So shortest raycast distance plus equals our skin size. And so that way we actually keep that barrier between whatever it is we're hitting, because that should always be there. And so hopefully this prevents our cube from actually falling into things. Well, that didn't work. Why are we moving backwards? Shortest ray distance minus our skin size. That should fix it. The jittering wasn't really cool, so we're gonna hopefully get rid of the jittering. I should move that down a little bit because we don't need to wait for this whole thing. Okay, that didn't work either. We just dashed right through our platform. So I think I was right the first time, and I screwed it up somewhere else. Let's see here. Why would this break? Well, actually, so shortest ray distance, we're adding the skin size, so that's going to subtract some small amount. That makes sense. The raycast seems fine. I think we don't want this, and I think we actually want to use the min. So there's a min depth. I'm going to use a name parameter here just so I remember what this is. We're just going to give it a skin size. Can we not use a named parameter? There we go. And so when we come to named parameters, when you have optional arguments to a function, you can use a named parameter as a way to kind of give them in any order. So we can have a max depth, for example. I think that's also one of them, and set it to like 10. You'll see this is the method signature is actually backwards. It's min depth and then max depth. We can actually flip those around if we give it a signature or a name. And it also kind of adds some clarity when we start getting a lot of things in here, especially things that we don't use a lot. Like min depth isn't necessarily clear why we're setting that to the skin size. Or at least just having skin size randomly in there doesn't make a lot of sense. But if we add the min depth, it makes a little bit more sense. So that's the motivation there. I don't know if that helps at all, but I'm going to do it. So let's move this down a little bit, just so things happen a little bit faster. We're still jittering a little bit. That's not great. And I'm not sure why either. because ideally we want this to move to the exact position that it should be at. Maybe we just don't need this. That doesn't make a lot of sense. We should need it. But. All right, so that moves us into our object. And so we need to find where we hit and move us back by that skin depth. So we have the shortest distance, and we add the skin depth, skin size, so we move away from whatever it is by the skin size. Huh. I'm not sure exactly why this isn't working. Because so we should have our depth, velocity to 0. I don't think we do need to reset our velocity because we're already hitting the object. And so like if I take off that subtraction there, we'll actually hit and sort of rest on the surface because we'll constantly be hitting the ground. And so like the problem we're trying to solve is this. We're clipping into the ground right now, and it's not by much, it's by whatever our skin size is. But we don't want that to happen because that doesn't look right. And I don't know why we're doing that. I would assume that we could just add our skin size, but that clearly didn't work. So something else must be happening. Hit distance. That doesn't make a lot of sense. That shouldn't change anything, right? It seems like we're moving by too much, if that makes any sense. Like we're subtracting by more than. Oh, that's what's happening. Okay, I get it. This needs to be divided by 2 because we're subtracting our full size of our bounds by however much by the skin size. But that's affecting the entire rectangle, not the specific direction. And so the actual weight applied to the other side is going to be half of that. And so we were actually just applying too much. That's why it was jittering back and forth. It's still doing it, but it's doing it less. Okay. Now it's just doing this to mess with me. No, that actually seems significant. So if I pause this, so we're jumping between half of our skin size and the full, or being at 0 more or less. So something weird's going on. Added dancing. See, but it wasn't intended as a feature, and I don't really want it to be a feature. Why would it do this? So the rigid body shouldn't be moving itself. It's kinematic. So our player actually, all of the player's movement should be happening in this script. And I don't think we need any other use of our delta time, because the skin size should be a constant. It should always be affected because effectively we have like a rectangle, And then what we've done is we've shrunken in. And then we're casting points from there. And so as we hit something, we want to move back out. And I'm not sure how we want to do that. Maybe the best idea is not to use these, if that makes any sense. So I think we can like, we have these 3 going down. We may not, maybe not use those in horizontal movement, if that makes any sense. And then only use the, like, use that to detect if we're on a platform, but not use that as a way to detect if we can move horizontally. And then use the higher points on our mesh or on our object to detect if we can move left or right. Does that make any sense? I don't know if that does. That seems a little bit convoluted and weird. The end of the time. So the idea of expanding the bounds is to move the points inside of our object. And so by moving each of the points we're calculating this physics from inside of our object, the advantage is that we don't run into problems with collision. So right now, if I remove that, if we fall onto the ground, what will end up happening is the points on the ground will register collision with the ground always, unless we have some sort of positive y velocity. So unless we're like jumping, we're always going to register a collision, and we don't want that to happen because that's going to prevent us from actually moving anywhere. And so we either need to move the points up or not use those points as a way to determine if we're actually colliding with things. The other alternative for velocity is maybe actually have some separate role for handling movement. Because effectively what we have is a way to detect grounding, if we're on the ground or not. Like, if it is hitting this else block, we're grounded, and otherwise we're not. And then if we're grounded, we can actually do something else to check our horizontal movement, and then have them like separate. So we have like a falling calculation and a other calculation. And then we can use like different sets of points. So like this will be our ground plane, effectively, like the character's ground plane. We can use other sets of points to actually determine where certain things should happen. I don't know if that makes sense. It seems like it might, but it also seems like that could get really complicated, because effectively we're going to have 4 sets of points then. We're going to have the ground plane for like grounding and hitting the ground and doing platforming logic. And then we're going to have the left for moving left and the right for moving right. And then the top for like hitting your head, or going through platforms or things like that. I guess the advantage of that, though, is it actually simplifies a lot of this. Because then we don't need to use these normalized velocities. We can actually just do velocity.y and min it with 0 for gravity. That could actually work well, I think. Because then if we do that, things like jumping through platforms, like semi-transparent platforms that you can jump through but not fall back down from, those become easy, because then we can just have only one side of them, like the gravity based ones detect movement and the jumping based ones not. Does that make sense? I feel like this could work, and we can make that into something handy. The downside is then we effectively have to do this 4 times. I don't know if I want to do that, but it's only 20 lines of code or so. So it's not that big of a deal. It fits on a screen. So maybe the hesitation is not worth it. Let's try it. So let's see here. Player movement controller. Here's the current modifications. Okay, that isn't anything. What? It doesn't show any changes. That's weird. But we do have all of our changes for the velocity and things. No, we don't. What the heck? There we go. All right, so we're going to add these changes in Git. Just for reference, made the player dance when on the ground. Great. All right, reusing other people's jokes. But there we go. That's actually going to keep that around for us, just so we have something to go back to, because I am going to break everything. So what we want is some way to move. So this is going to be our void fixed update, which we're going to copy, and this is going to be our fixed update move down. And so everything we're doing here is only for moving down. And so we're not doing this. We're actually doing our velocity dot magnitude times math f dot min of our velocity dot y and 0. So if our velocity is negative, like we're falling down, it will be whatever that is. Otherwise, if we're going up, it's going to be equal to 0. And so that's what this is here for. Everything else should be fine. Movement length, and then our velocity is actually not going to work with any of this. It's actually going to be based off of our vector3.down. And then for the bounds, we can just not use any other stuff. I don't know if this is a good idea. We're gonna try it. Move position, velocity.normalized. This is actually velocity.down times the shortest raycast distance, vector3.down. And I think that's everything. The downside of this is now we're doing some gross stuff, but we'll see. So yeah, if I did that right, we should still be able to actually fall vertically. That's a good start. Guess not. What's going on? First, we should get rid of this. The skin size doesn't need to be there anymore. And neither does this min depth. So we don't need that. Everything else is fine. We can pull off this skin size and try again. And really what I'm doing is just going through and deleting all the stuff that we don't need anymore until we get to a thing that works again. We're still not moving. And I believe that's because we're hitting ourselves. No, we're not. Save our scene, because I hadn't done that yet. And move position, vector3.down, velocity.y. It should be negative, so that should be working. We don't need the magnitude times our min of that. That doesn't make a lot of sense. Because that's gonna just double everything. So we don't need to worry about that. Let's see here. Do we even have our points? No. All right. So that's what's going on. Oh, duh. We need to call the new function we created. that would help a lot, I bet. So good news is I don't think I broke it. Now we're just going up. Great. And the reason we're going up is because we have velocity y. That is actually a negative value, and we're multiplying that by vector3.down, which is also negative, and that translates into going up. And so we need this to be negative. And hopefully that ends up translating us into a downward movement. It is true. We can't break our code if we don't call it. And so now we are pretty much directly on the ground, which is exactly what we want. And that calls most of our gravity stuff. So gravity is good. We actually move down. Now we need something for a fixed update. Move. We can do horizontal, all as one, I think. And then fixed update move up as something else. And so that one's not going to do anything for now because we're not there. But we have this moving up. And then our void fixed update move horizontal is going to do a bunch of other things. So we're just going to copy and paste. Typically when I'm doing something like this, I will copy and paste between two different things, and then usually go back and find all the parts that are still the same and pull those out into functions. But we're not there yet. So right now everything is just going to all be together, which is not great, but that's where we're going to be. So for this, we can plug in this transform .position.y. And so all three of these are just going to be at the center of our player. And then this will be in the center, and then on the left and right most bounds, we need a movement length, which is going to be velocity dot. Do we need to do anything with this? I think we can just grab the velocity dot x and use that. And so right is going to be the positive, so we're going to do a vector3 dot right. And since we're multiplying it by the movement length, theoretically we should be fine. And so it should work. Like if we give it a negative number, the ray is going to go in the opposite direction, and so that should be fine. And I think that's all we need to change. And so this is going to actually handle moving us left and right, and not handle moving us in any other direction, hopefully. And so as a way to test this, let's grab our scene, copy this, and rotate it 90 degrees and move it over here somewhere. And so if we go to the left, we should hit a wall and not go through the wall. And if we go to the right, we should go to the right. That's the idea here. So set that equal to 1, and we don't move. Well, it was a good thought. Why didn't that happen? Move horizontal, so that's still there. Movement length, we have our velocity. Raycast hits. That seems fine. That will move us if we don't hit anything. And then if our hit distance hits anything, that will move us to the shortest point. Okay. I think that makes sense. Everything seems like it should work. So I've done something else. What have I screwed up? Is this used? I don't think that's used anymore. No. All right. We can delete this then. All right. What am I screwing up? There's I guess an easier way we can do this. We can move that down below. Did we win? No. Maybe? Yes? I'm not sure you can win at this game. Why is that not moving at all now? What? Hold on. What have I done? Why isn't it going down? This is weird. Huh. Okay. I don't know what's going on anymore. It doesn't move anymore. So if we only do our fixed update down or horizontal, we shouldn't get any downward movement. But if we set this to have a velocity of like 1, we'll go to the right, and this should go to the left until we hit that wall. Maybe. Yes. There's a little bit of jitter again. I'm not sure where that's coming from. That's not a good thing. Why would we... Huh. We can move down now. So there's some progress. We've tried a few different things. I think this is probably the most promising of the solutions we've attempted. But I think there's room for improvement still. We're bouncing off of the wall now. And I don't think that's good. So we have our shortest raycast. All of that's... Oh, that's what's going to happen. Okay. So our shortest raycast distance is not necessarily going to work. Because we're going in one direction, and we actually want the shortest total distance. So I'm going to take the absolute value of the distance. That will make sure we're going in the right direction. Because otherwise we're taking the minimum, which means if we're going negative, actually the longest vector is the best one to choose. And we don't want that. So instead we want to take the absolute value, which will find us the shortest length. And then instead of moving by that shortest length, we're actually going to move by our sine of the thing. Not sine is in sine and cosine. Sine is in like sine in front of it, like plus or minus. And we're going to take the velocity x sine. There we go. All right. Hopefully that helps there. And then we can see what's going on. So that's going to move us in one direction. And so if we do -1, hopefully there's no bouncing. Yes. All right, so we smoothly hit that, and we can stop. And we should be able to go in the other direction. I'm not going to test that right now. Let's see here. Now, let's add our fixed update move down back in. And I think this is going to break a few things. I'm wondering if it's because we're using two moves in the same update. I don't think you're supposed to do that. And so that may be what's causing this, but it seems like we're still fine. But I think the first move is the last move is the only one that matters. And I would guess if I had to, that there is some sort of modification here. So let's do translation equals vector 3.0. And we're going to do translation plus equals this and this. And we're going to return a vector 2 from this. I think that makes sense. And so instead of moving position, we're going to give back the the relative position that we're going to return, or we're going to move. So return here and this. And we can drop some of these parentheses just because we don't need them. And so this way we can actually sum up the entire movement we're going to do. And hopefully at the end of that, we can actually move. So we'll have our rigid body dot move position, this transform dot position plus our translation. The downside of this is we aren't actually validating that we can get to the actual point we move to. So that could cause some weird issues. We're actually only validating that we can move in any of these specific directions. So there may need to be a few extra checks to make sure this is actually a valid move. But we'll see. The other alternative is to actually plug in this translation so we can actually have like maybe gravity take priority and then use that new updated translated thing as a way of seeing how far we can move horizontally. That could be an option too, and then we don't have to deal with a few of those other side effects. Let's see here. It doesn't understand between vector 2 and vector 3. Let's do vector 2. All right, let's do a vector 3. Doesn't really matter. There we go. And we're not returning anything from this function, so let's do that. Invert the velocity force before applying it to the position. I'm not sure So I've tried something like that in the past, and it usually results in like the jittering that we were seeing previously. So I'm not sure if there's like a better way to get around that, but that's been my experience, is just we get a lot of jittering. So this way we fall to the ground, and if I increase our velocity in one direction, we'll move along it. And if we go even faster, we should hit the wall and just stop. So that means our movement is mostly working. The only thing we don't have working is jumping, so we can't jump yet. But everything else seems to be fine. And we could repurpose this up and down movement as a way of doing jumping as well. But yeah. I think we want a separate logic for moving up so that you can actually jump through platforms, and we don't need to do a lot of extra work there. Whoa. So vector 3. Like this. And what do we want here? We want this to be the max for the Y now. And I think that's like the main difference here. And then we want our max velocity here. So that we'll always get a positive number or 0. And the distance can be min. So that should work for hitting our heads. And then this is going down. We want this to be up. Ups. There we go. And I think that's everything. I could be wrong though, but we'll see. And then I can fix up everything else off camera. All of that extra code, we probably don't need that to be done here. Let's see, we can copy that and let's put that at like 5. Sure. And let's move our player up now. So they now have a positive velocity, so they should hit the ceiling and then stop. And so this way we can actually detect if we run into a ceiling, if we hit a floor. So if we fall and hit a floor, we'll hit that. And this way we can go off. Oops, I broke it. Let's see here. How can we do this? Pause it and go to like 1, 0 there. But we'll hit sides and not be able to run into them, and be able to do other things. And this way, hopefully we can actually do some extra work to like jump through platforms or modify them in other ways. But I think that's mostly character controller stuff. And so all we need now is something that makes this velocity not static. Because right now it's just a very static thing that I'm setting manually. We want to tie this into input somehow. So I think we can do that next. So we can keep the velocities set on that object for now. Let's just add a really basic input controller. We'll just call it the input controller. And we should probably commit this. So let's do, this, add that. I really need to get a git ignore in here. There's too much stuff. Let's see, player movement controller, add vertical and horizontal movement. Cool. All right, so there's that input controller. Let's actually jump back into that. And we want a reference to our private player movement controller. And so that will be our movement controller. We just need to initialize that. So we'll grab that, get the component, and then we need to actually translate some of our inputs into that velocity. And so we want to do something like movement controller dot velocity equals something. But I don't actually think we want to directly assign that from our input. We want some sort of acceleration. And so let's do a public float max horizontal speed and set that equal to, say, 10. That might be a bit fast. 5. And we'll do a public float something. This might be a little bit harder the way we're doing it because we don't actually track if we're grounded or not right now. And so that may not be great. Let's assign that. So public bool is grounded. We'll set that to false by default. And that's going to be handled by our vertical down movement. So is grounded equals false. If we don't hit anything, or if there's nothing that we're going to fall onto, then we're not grounded. Otherwise, is grounded is true. And so with this, we should be able to actually use that to reset like our gravity, for example. So public float gravity amount 9.8. We'll just use defaults for now, but we can change that. And so float gravity equals time dot delta time. So the difference here is I'm actually using our update as our input layer and our fixed update as our physics layer, which might be a little bit weird. and we're going to be using like two different things, but update or input tends to happen more. And so just putting it on the update layer, I think it still works in fixed update. It just, you can drop inputs that way, I think. And so we don't want that. And so what we're going to do here is just multiply our delta time by our gravity amount. And that'll be our amount of gravity to apply to this velocity. So we're going to do plus equals our vector 3, that down. The input controller controls the gravity for now. This input controller is sort of a kludge to kind of cover everything that I didn't do in the movement controller. There'll probably be other things that handle those extra forces like gravity, but for now, just to kind of get it all working and so we can actually get like a jump arc going, we need something to provide it, and so that it's going in here. I agree, it's not the best, but it's where it's going. So then for everything else, we need something to handle our horizontal movement. So movement controller dot, what do we want? Velocity plus equals our vector 3 dot right times our horizontal. Something like this. There's going to be a bunch of like gross code happening here because I don't intend to keep this, and so we're going to cut at corners. So horizontal is going to be equal to our input dot get axis of our horizontal axis, and we're going to multiply that by time dot delta time and our horizontal acceleration, which doesn't exist, so we should create that. All right. Public. So we are going to end up clamping things. I don't know where we're going to do that, but it'll happen eventually. So the max horizontal speed is there. We're effectively going to assign, like I'm using this movement controller's velocity as a working thing, which isn't good, and I shouldn't do that, but I'm doing it. And so we're going to do this, and then we're actually going to clamp it at the end. And so the idea here is like movement controller dot velocity equals movement controller. What do we want? New vector 3, I think, of a movement controller dot velocity, and we're going to multiply this by another movement controller dot velocity. That doesn't make any sense right now. That's fine. And we're going to do that again with the y. The y I'm not going to clamp right now. And then the z doesn't need anything. And so what's going on here is we're going to do mathf.absolute of this and the mathf.sign. And so this will allow us to move in a specific direction up to a specific point, because now that we have an absolute value of this, we can clamp it. So mathf dot min. We want the minimum value of either the absolute value of our x velocity or the maximum horizontal speed. And this is gross and I don't like it. But again, it's a testing thing, so we're going to keep it. Sign of this dot x, there we go. And then the only other thing we need is if input dot get axis of vertical is greater than 0, and our movement controller dot is grounded. So this is our jump. This is a bad way to do a jump, and we shouldn't do this. But again, this is mostly to get it so that we can work on platforming and actually get that working, not so that we can get correct input stuff. That's more complicated and is probably an entirely separate stream where we can break that as well. So the vertical stuff is detecting if it's greater than 1 or greater than 0. So if we push up on our keyboard, that will be that. And if we're on the ground, then we'll jump, which is going to be that movement controller dot velocity. This is really bad. New vector 3. So it should be, there should be some acceleration, but it's acceleration because we're actually like adding on this horizontal over time. And we'll actually like build up our velocity, and there's no friction, so we'll actually just keep it and just kind of slide around, which isn't great either. But we can explore that, I guess. You know, there are a lot better ways we could do this. Hold on. What am I doing? Float speed equals movement controller dot velocity dot x float vertical speed. Let's just call this speed and do a vector 2. So this will be our speed. We can just copy that over. Cool. That's much easier. And then instead of modifying this, we can just do speed and speed. And this can be our speed.x. And we can drop all of that other stuff. And I think I need one more parenthesis. Can I not assign that? Oh, I'm not assigning it. That's why it's breaking. All right. So there's all of that. That's gross, but it works. All right. What else is going on? Our vertical, we're going to do speed.y equals our jump power. Sure. We don't have that, so let's do power or public float jump power. Set that to like 10. Just guessing on these values. I have no idea if that's going to be good or not. Maybe that works. We need to actually assign this back though. So we need a movement controller dot velocity equals, can we just do this? Speed dot, or velocity equals, hold on. Yeah, we can just do this and assign it back. That's gross, but it works, maybe. We'll see. I don't have confidence in this, but that's fine. Yeah. It doesn't. Oh, of course it doesn't listen to me because I didn't put a input controller on our object. That's required for this. Otherwise, this really isn't going to work. So the coding with an audience thing is interesting. It took me a very long time. Hey, look, jumping works. It took me a very long time to actually like get this channel working. And when I first started, it was very difficult. You just kind of get used to it. Like I've done 300 plus videos, and after a certain point, it's just another video. But like the first ones, you can tell, like if you go and watch some of like my really old videos, you can definitely tell like just everything was different. And you don't have that. But also you kind of like making mistakes happens, like it's just going to happen. And so like to some degree, like you kind of have to get to the point where you're okay with those being a thing. But yeah, I don't know if that's helpful. But that's sort of like where I ended up finding myself, is like I was at a point where it's like, yeah, I'm gonna screw things up, and that's fine. um and some people really don't like that. Like, every so often there's somebody who comes in and is like, why didn't you do this, or write this right, or whatever. And like the entire point of this channel is like, this is me learning. uh and so like, if you're looking for like the best solutions to things, you're not necessarily going to find it. That isn't really what it's for. um and so like, you just kind of figure that out. Well, I think like, it's not necessarily like, solutions aren't the best, or they're not like fitting it up, but like, we've spent 3 hours here trying to figure out how to write 160 lines of code. And realistically, like, if you had already done this, this is code you would be able to do in sorry, in just a few minutes, or like less than an hour. um but because we're like walking through this for the first time, you don't really have that advantage. And so if people are expecting that, like some other different, like very specific tutorial based examples go, you'll get different things. So yeah, I guess that's sort of like the difference. um I personally like the coding train, for example, a little bit more than some of the other tutorial sites. Personally, I find it really hard to watch video tutorials of things because they go too fast for me. And so I tried to make something that wasn't quite so fast, and was kind of like, why are you making these decisions? And some people like that, and others really don't. So I don't know. You just kind of have to get used to it, I guess. But if this is something you're looking to get into, though, I will say, feel free to reach out to me. Like, I try to respond to things. And I don't know. I I would hope that if it's something that you want to do, that we can get to a point where you're confident in doing what you like to do. So that's what I would say. Yeah, I think so. I think the coding train is probably my favorite programming thing. Just because he's such a cool person. Like, he's really charismatic and really outgoing, but also like, he knows what he's talking about most of the time. And even when he does, like, he'll screw up, or whatever, he he makes it clear, like, that's fine. And kind of uses that as an opportunity to help other people learn it. And I think that's pretty cool. All right. I lost where we were. What were we doing? We were fixing this gravity thing. So I was noticing that the velocity was constantly increasing while we were grounded. And that's not great, because it means if I were to run off the edge, we would just fly off into the ground. That's not great. So this is going to reset our gravity amount every time. We probably also want to max like falling speed, but all right, gravity amount, that's set. We can't move horizontally or vertically anymore, so that's not a good thing. Oh, that's because this is below everything else. So that needs to go up here, and that probably still isn't going to work, actually, because since we're grounded, we're going to run. Oh no, it's fine. Okay, I was worried we were going to run into our other thing. This may not be consistent, so I'm going to test it. But yeah, okay, this seems fine. I was concerned that because we're testing for is grounded, and we actually look at a fixed update, which is what updates this, it would be possible for us to try to jump on one frame and then have our fixed update happen, and not jump anymore. So because it would cap our speed. So effectively, you could say jump and then get back to an update before another fixed update. Have it say we're grounded, and reset our Y velocity. So we remove the jump effectively and drop that input, and then hit our fixed update to update if we're grounded or not, which would just mean that we would never detect the jump because we're actually doing a getting our axis instead of actually looking at the button press. I think we're fine. So let's see here. We aren't moving horizontally. Why not? So if we do the fixed update thing, we'd have to actually move this like jumping itself into the logic for the movement controller. And what I'm really trying to do is have like actions that you can perform, like jumping or moving, be independent from the actual movement. And so that just giving it a velocity and having that be the controlling factor and everything else being like an input into that. There might be other ways we can make that work. Like maybe there's actions or something that will modify the velocity and we can store those up in some list and then pass that into this. That may work, but I don't think I've ever watched Thin Matrix. I may have to check that out. I will leave a note. But yeah, there's a lot of really good like streamers and YouTubers that have popped up in the past few years. So it's pretty cool. Especially like with game jams like Ludum Dare and things. There's a lot of really fun things that people do to kind of share what they're doing. Let's see. Why don't we move? That's the weird thing. Horizontal acceleration is 10. So that gets plugged into this. Speed.x plus equals this horizontal, and minus equals our gravity on the y-axis. There we go. I feel like we should be moving, and we aren't. All right, why not? For some reason, we don't... Oh, is it? No, we don't reset the X anywhere. So that doesn't seem right. All right. So where we're at is this is broken. Oh, why are we doing this twice? This isn't gonna work. All right, well that makes this easy. So we can do our speed.x and plug that in. We were looking up the original thing and only using that, which is always going to mean we're staying at 0. So that should fix this. Well, we can go right. So we've built Mario. We can't go left though. We just jitter back and forth when we try to go left, which doesn't seem great. And I'm not sure why. We want the minimum value of our absolute value of our speed.x and the max horizontal speed. This should be speed.x. That might help. Otherwise, we wouldn't be able to ever change the sign. So that's not great. There we go. And now we're stuck. Oh, because okay. So we ran into the wall, and now the point in the far left is inside the wall, and so we're stuck. We can't move, and that will actually prevent us from jumping too. Okay, that's interesting. I don't have a solution for that. We may want something better, but this feels like good. Like there's some acceleration to it. You slide, obviously. We don't necessarily want that. Maybe there's a way we can solve that as well. Let's see here. Speed.x equals. This is a bad idea. This isn't right at all. But this will at least get us a little bit of slowing down. Time to delta time. So this is going to lerp towards 0 from our current speed by the time delta. So it should very slowly move towards 0. This isn't how you do friction. This isn't how you're supposed to do anything. But we're gonna try, and we'll see how this goes. And so we do slow down a little bit. Those green lines are a little bit distracting, but that's just normal gizmo stuff. So we just need to make sure we don't hit the wall, I guess. Everything else seems to work though. So we can actually move around. That was a little bit strong. Okay. We are setting this to our negative gravity amount. And that should be equal to 0 instead. Or actually, we could just set it to the negative gravity. Or just plus, and we'll do negative gravity there, I guess. Really, we should probably just do this and set it to negative as the input. But we fall really fast when we run off a cliff. So, whoa, okay, we just flew off into the air. That's not right. There we go. All right. And so now we can jump, and there we go. When we fall off of a cliff, we actually fall relatively slowly. So that seems fine. What else can we do with this? Put this like there-ish. I'm just kind of exploring this because I'm not sure where we're going next. Cool thing is the way we have this means we can actually just like run over these walls. So that's nice. We'll still get stuck though against walls like this. It's like right now we're trapped. We're floating in the air and we can't fall down because the left hand side is actually saying we're hitting a wall, and we can't go horizontally either because we're actually hitting things there as well. And so that's not great. We want something to make us avoid that. I'm curious. This might not work, but if we do a min depth of the, do I still have the skin? No. 0.01 F. I'm curious what this will do. It could break things. We might just run into a wall a little bit. But I'm hoping this will prevent us from actually getting stuck in the walls. Oh, it will mean we'll fall right through because we'll snap directly to the surface and then we'll fall through it. So that doesn't work. All right. That's interesting. is there a way we can modify this? So like we have these bounds. What if we bias them in some way? So like if we do plus the velocity.x times some really small number, that doesn't seem like a good idea at all, but let's try it. That's moving us down, so we don't necessarily want that. But we do want to do our horizontal movement. If we modify it like this, is that enough to get our collision out of the box? And so like we move left, and we go right through the wall. That's interesting. That wasn't what I expected to happen. Interesting. Okay. I don't know what's happening here. Oh, okay. Well, that we can't fake it apparently. Yeah, I think like we could move everything in a little bit. So I think we want like plus 0.1 and minus 0.1. So like this should work, at least for the horizontal stuff. It will just mean we'll move into the object a little bit, I think. What the heck? Why? What have I done? Or do we have something else going on? Why are we moving through things all of a sudden? That doesn't seem right. Maybe like, huh. Yeah, I've changed something else. And I don't know what. Bounds. Oh, it's right there. All right. All right. Did I leave any others? No. All right. Let's add this back in. Velocity.x times 0.001 f. Cool. And let's do that. And so what I'm hoping this will do is it will extend our collision box just slightly to the left when we run to the left, and then just slightly to the right when we want to run right. And so that will prevent us from actually getting stuck. And there should just be the tiniest of gaps. You can't even tell. Yeah, so that seems fine. I don't think anybody's gonna notice that, especially when we actually swap in like actual art. I don't see that being a problem. It might cause you to get stuck a little bit because it's cheating to accomplish this, but on the other hand, it might work. So we will see. We can actually do that for jumping up as well. And so here we want to add our velocity here, the y velocity here, and that should prevent us from getting stuck into the bottom of the ground, though that actually isn't right. We want to use the x again, because what's happening is we're getting stuck into the walls, the vertical walls, and so this is actually still right. So move up, it's right there. There may be some consequences of doing this. we may be able to stick to the side of walls. No. What? Well, I broke it. This isn't good. Well, I guess we'll figure that out. But apparently we can fall into objects, so that's great. That's not supposed to happen, but yeah. Should the last raycast be minus? The fixed update move up. It's using ups and not anything else. I don't think we're using. No, everything here is positive, so this should be fine, I think. So I think that logic is good. In the origins. No, that would expand it, I believe. Because really what all this is doing is just a more fancy way of doing like plus 0.001 and minus that. It's effectively doing this just without doing that. Honestly, that may be better. So let's try that. Let's see what happens. Or can we fix it in another way? What if we subtract something larger? So the move up and move down, we can subtract larger values, right? Because if we do large values, we'll end up with like some weird triangle-y thing. Like we'll have points. Our horizontal points will be farther apart than our internal points, and so you'd have to move out. This might be a bad idea. But it means we can like jump directly against this wall. And then we get stuck. Okay, that's not a good idea. Let's not do that. It was an idea. That's about all I can say about that. Yeah. I think we can just go back to what we had and just do adding and subtracting these very small numbers. I feel like that's probably going to be the best for us. I also feel like this isn't actually going to solve anything for us, if that makes any sense, right? Because the only difference now is that we're, yeah, back to the normal point. So now we can still get stuck. So I think we do need that velocity in there. So we need the velocity for the horizontal stuff. Huh. Is this fine? I don't think this is fine. We'll see. I think we're at the point where we're shouldn't there be an offer on move horizontal in the Y part? I don't think so. So like what we're doing right now is we're modifying where we're casting these rays from to prevent us from getting stuck inside of this wall, this horizontal wall. And so by using the velocity here, we're actually able to move out because our velocity becomes the opposite direction. And so we can actually go in the opposite direction. What I do want is to make this a little bit more responsive. So right now we add the horizontal But we only want to do that if, let's see here. We want to match the velocities of these two things. So if we're going to the left and we try to go to the right, we want to turn around. Do I want that to be instant? I don't think I do. I think we can actually fix this in another way. We can increase the acceleration. And so we can actually just make our player move faster, or accelerate faster. So if we crank that up, we'll reach that top speed faster. And so when we need to change directions, we can do that just a little bit, and there's just a little bit of sliding. I think that makes some more sense. Okay. Yeah. And then if we want to change things like if movement controller is grounded, we're going to do 2 of these apparently. But if we're grounded, we want to do something else. Or if we're not grounded, rather, we want to multiply our horizontal speed times our air velocity change, something like that. So we can actually be less mobile in the air, for example. And so this will allow us to kind of tweak how effective maneuvering in the air is versus on the ground. And so we can set this to like 0.5, 0.3, something like that. And so when you jump, it actually becomes harder for you to turn around. And I think that will accomplish that. There's probably a few other things that we need to consider, but for the most part, like, you can move around and you can kind of jump around and do certain things. And I think it's pretty predictable. Like you kind of know where you're gonna go, and so you should be able to make these jumps. I would hope. So I think the next thing is actually like doing platforming stuff. Maybe I'm missing something, but I think we're pretty close on this. There's a few other things we need, like that jumping is weird, but and that's weird. If you try to go into an object, you'll actually snap into it. Double gravity when falling? I'm not sure I understand. I know in Mario, like, different things fall at different speeds, but I don't. Or do you mean when the so when the gravity, or when the player is moving in the negative y direction, that the gravity is twice as strong? Because that's easy enough. If the speed dot y is less than 0, then speed dot y plus equals gravity. We can just turn this into a ternary operator and just do speed dot y less than 0, or greater than 0 rather, then do gravity, otherwise gravity times 2. Why doesn't it like that? Oh, doing the ternary operator in the wrong direction. There we go. All right, so that fixes it. So now if we're falling, if we're in the negative direction, okay. Yeah, I kind of like that. We'll see how this works. Yeah, I think that feels fine. I think it also helps with accuracy, because like we still need to figure that out. But because you fall really fast or faster, it makes it easier to like get above something and then fall on top of it. All right, cool. now we just need to figure out why we clip into that object there. I think what's happening there is our horizontal tests are only in the center. And so we need some other ones. Is this a good idea? We'll see. But I think we can just take fixed move down and plug a whole bunch of these new ones into this. And we want to add some extra value here. So like 0.025 or something. F, there we go. Found it. And actually get this to work. This might be a little bit much. All right. I don't think we need that one. This is in the middle. I might just leave it there as like an extra bit. And I'm not adding anything at the top either. So let's do that as well. This might be excessive, but that may be fine. And then I'm just subtracting this so we don't have we have like some sort of shell around the outside. And that should prevent us from going too far into something or getting stuck, because that wouldn't be very fun. All right, there we go. And we're stuck. Well, there was an attempt. All right. So for whatever reason, we slide into the ground and stop. Oh, this needs to be a plus. Wait, what? Those don't seem right. These values don't seem right at all. Minus. This needs to be a max. There we go. That seems like it could work. All right. And so hopefully now we don't hit the ground and we don't get stuck, and we can move around, but also we don't clip through the side anymore. So we kind of bounce off of it until we get above it. And I think that's more what we want. Yeah, so I think adding like special jumps to like go higher by like holding the jump button down, or even having like multiple different types of jumps. Like I know Mario has like long jumps and spin jumps and high jumps and all this other stuff. I think we can add that mostly by just modifying like other rules. And so like one of the things that I really want to add to this is like a combo system. So you can like maybe hold a button or do some other thing in order to accomplish like more movement. And that way, hopefully we can introduce like a bunch of like both combat tricks, but also like movement capabilities. And just so you can like do all sorts of things, do all sorts of things to like move around. That's sort of what I'm hoping for. I don't know how well that's going to go. We've tried that in the past, but we'll see. For now, I think this is pretty all right. It's still very slidey. So we can adjust that by modifying this lerp wherever we put it. And this spaghetti code needs to not be a thing, but it is for now. We'll modify this by like adding 5. So this should prevent us from sliding a little bit more, and we should actually like slow down. Still not the best way to do it, but it gives us sort of a nice like smooth thing. We only want that applied when we're not grounded though. Otherwise we want you to maintain your velocity when you're in the air. So we have like 3 of these is grounded checks for different things. That's probably not great, but we're making progress, so I think it's good. Yeah. For the most part, platforming seems done. There's a lot of hacks to this still. And like we don't lose our velocity. Like if we hit this, we don't lose the velocity, and so we kind of like pop over the edge and like fly off. That's not great. I think we can fix that though. Let's see here. Update horizontal move speed. In here, we actually want to set the velocity dot x equals 0. And so that will zero out our velocity and we'll stop. Here we want is grounded and velocity equal to, or velocity dot y equal to 0. I don't know if we actually want that there. And we need that in the up as well, so that we, like, if we hit our head, we actually stop moving up and don't do anything else crazy. Otherwise, if we keep that, what's going to happen is we'll like stick to the ceiling for a bit, and that's not going to look great. So hopefully we can avoid that. Let's copy this and put this like there. Oh, okay, we can't jump anymore. Pretty sure that's caused by this. So let's pull that out for now. Oops. Yeah, not sure what's causing that, but we'll see. Yeah. Can we jump? Yes. All right. And now you can see when we hit the side there, our horizontal velocity gets zeroed out. Like those red lines end up going straight up. Looks like we can still end up on the platform there if we do it right. But I think that's just residual velocity going on. All right, that's good. Good. Things seem to be going fairly smoothly. What happens here? Yeah, this is the sticking to the ceiling thing I was talking about. Because our velocity is still going up, we actually just stay stuck to the ceiling, and that isn't great. So let's, can we do that here? Velocity.y equals 0. The gravity boots feature? Oh yes, yes, that feature where you're suddenly a spider for like half a second. Yeah, and that was intentional. Definitely is not a bug. Couldn't be a bug. But now we actually hit our head and can't jump. So that seems good. Let's move this a little bit over and further down. Even further down. There we go. All right, so we can actually like hit our head there and then bounce and get up here and jump over here. Everything seems to be going fairly well. We seem to have a working character controller. There's some quirks that we'll probably run into. I imagine as we like put this under test or something, other issues will come up and we'll actually have to figure out what to do with them. But for now, I think we're in a pretty good spot. It seems like it works, and we've covered most of the cases that I wanted to cover. Things like that can happen where we just get stuck inside of things. And we'll need a solution to that, because I don't know one off the top of my head. But if you get stuck, that's not great. And there isn't a good solution there. So yeah, I don't know. This is really as far as I wanted to get. Like get basic movement done to the point where we can actually like control this and do certain things. we can probably go, well, refactoring it is going to take a while, so we're not going to do that here. But there's maybe other things. I don't know. But yeah, I think that's mostly what I wanted to cover here. The other thing that we could do is take a look at our MC clone project, which is in here somewhere. It's not in here, is it? Is it called the Spigot Hello World? Have I not renamed it? Yeah, it is. Of course it is. All right. So what's in here? Is there a Gradle project? Nope. All right. Let's go into our Hello World thing. And there we go. We're just randomly changing our goal, I guess, and moving to something else. So this is MC Clone. I think that we'll start working on this a little bit. I don't know how far we'll get. We've been streaming for like 4 hours, and that's a long time. But I kind of want to play with this a little bit and kind of see where we get. The goal of this is to be able to clone a Minecraft world and actually be able to like modify it in your creative space without having to do anything. So let me see here. So if we sign into this server quick. Oh, he's angry. Oop, sorry, one sec. Definitely not hiding things. All right, there we go. Hello. All right, so let's say we have this server. Had this server. Why can't I? This is going well. So if we have a server, let's say we want to build something like here. If we wanted to do that, there's not really a good way to like see how it's going to look in our world without actually like exploring it. You have to actually like do something. And so like if we want to build something here, the only way to make sure it like fits is by like building a creative thing and then moving it to the server and hoping that it still looks right. And that isn't necessarily great. So the idea of MC clone is we would be able to type like MC or like clone world or something like this. And that doesn't exist, obviously. But we'd be able to type that and get a duplicate of this current surroundings. And then that would show up as a separate server. And we'd be able to move over to that server and actually do like our creative project. And then bring it back here. And so effectively creating creative projects of existing worlds in a way where you can actually work with them with new settings. So if you actually want to like mess with them, you can do that. So that's the goal there. We're gonna just cancel out of that. And so this is the project. All it does right now is set up a really basic, where is my actual code? All it does is actually like create this command by that allows us to actually print something out and send a message to a player when you type something. And so what we want to do is like do Gradle Minecraft. And so this is a custom Gradle command that I wrote. Where is it? In here. It does some interesting stuff, and mostly what it's doing is spinning up a Docker image for you that has a Minecraft server in it. And so that Minecraft server is then going to load up and build your existing code, your plugin for whatever Spigot project you're working on, and then it will start a server for you with it. And so it's currently compiling. It will do Docker stuff next and then start that. This is the first time we're launching it in a bit, so it might take a bit, and it's broken. That's great. What's going on here? Apparently, I don't have Docker running. What's going on? We'll see if that works. No, we're not gonna. We're mind me later. Skip that. All right. So we need to wait for that to start up. Well, you need a Docker daemon running, otherwise you can't use Docker, so you can't use this. Everything else still works. So like we can do Gradle build, and it will build our plugin. We can test it. We can run some tests. There aren't very many tests right now. 4. That's not the number of tests. What am I talking about? We have this test and this test. So this one checks if we can create a new file and if it exists. And this one is just a testing for 4 strings to see if they have the same count. This is like a super simple sample thing, but that's enough for that. Do we have it running yet? I suppose I could have actually tested it. It doesn't look like it started, so this probably is going to fail as well. But yeah. So what I wanted to get done here is actually figure out how we can copy our world. So it's all running. The intention of this is to run it in a Minecraft server, which means you need to know where your Minecraft stuff is. And then once we have that, hopefully, what we can do is actually pull out a bunch of information. And so what I was hoping to do, there we go, is run this and get a copy of our terminal. It's going to look a little bit gross because we have 2 terminals in a small space. But that has started our server. There's some extra information here. Ignore the fact that it's still executing. This command doesn't exit until the server closes. So the server has been created. We just haven't actually done anything with it. And so we're going to actually copy that hash and do a docker exec it of that. And we want to run bin bash. I think that's right. Yeah. And so what that did is actually exec into our Docker container. So the Docker container is the thing with this hash. It is flags to give us an interactive terminal in Docker. And then bin bash is the command we're actually running. In this case, we're just running bash. And so now we're actually not on my computer. We're actually in the Minecraft server. So if I do, that's not right. ls, where are we? So we're in a folder called data. And we can kind of explore this and figure out where we need to go to get all of our world information. Most of that is in this world folder. And so there's this data packs, region, player data, things like that. We might just be able to copy the entire like data folder. Does that make sense? And then extract that and be able to use that as our template project for our world. I don't know exactly how we're going to get this information out of our Docker image. You're not really supposed to do that. So we'll see. We may need to actually like package that up and send it to some server somewhere in order to get this to work. But for now, what I was hoping to do is be able to have this command run something. And so we can actually connect to our local test server. And so this will be a brand new world that we just created as in this Docker image. And so we're here, wherever here is. And now if I type world clone, actually type the full command, we get creating a new server, please be patient. And that's actually everything running. And so that's getting executed right here in the sender.send message. And so we should actually be able to see that happen. I think that's mostly what we care about. all we need to do is now, instead of this, like sender.send message, we need to dispatch some event somewhere that's going to actually collect this data folder, zip it up, and send it somewhere. And then sender.send message, server created. You may join at localhost. There we go. that isn't right, but effectively we want to do things in here, and then here we're just like saying the command was received. This goes directly to the player that asked. It doesn't go to the rest of the server. And then this other one is just going to say, we're done. We've done what we needed to, and you can actually go and use the thing. And so in between here somewhere, we actually need to do something. And so I think we just need to go and grab that file somehow. So it's been a while since I've worked too much in Java land for file stuff. An object to iterate over things in a directory, that might work. So if we create a new directory stream of, I should look up how to use this. Oh, there it is. There we go. Of a path, and do something like this. It's gonna expect something, isn't it? All right, so files, new directory stream, got it. So Java is a little bit different than C#. It's a little bit older, I guess. But it has some very nice new APIs that have been introduced recently for like streaming things. And so that's sort of what we're doing here. New directory stream, and we're going to give it a path. Path dot. What do we want? Something. A new path. Does this work? Data. I don't think so. Cool. All right, so we're going to import path. It doesn't know what we're doing, so we need to actually use it right. What am I doing? Path. The project for this path, and then the path definition. That is very, very late. Yeah, have a great night, and thanks for tuning in. Appreciate staying up late for some of the help. And hopefully we'll get back to the platformer stuff shortly, or sometime later this week. Who knows? What am I doing? Project? No. Okay. So we want to pull out our data path. This isn't how we do that though. So I am going to go and look up how we actually do this. Let's see here. Java path. Can't search for Java path because that's a different thing. All right. So what does path do? How do we use this? Get path. This doesn't seem right. Why do we want to do this? And so if we use file systems that get default that get path, and then give it the path, we want like data, but I don't think that's how we want to do this. Does this work? All right, so we need to handle our exception. So we'll just cheat a little bit and surround this with a try catch for now. That's just going to catch everything and print out errors. That should be fine though, because mostly we're trying. What I'm trying to do is get to the point where I actually have information that I can use to actually test this stuff. And so what I'm hoping to do is get here and then be able to stream dot for each path. Java is a little bit different than C#. It actually uses these arrows instead of the equals and greater than, or yeah, greater than sign. So that's a little bit different, but that's just how this works. Let's see. We need to give it a type too. Path. There we go. And it expects us to do something here. And so we're just going to do system.out.println test. Why doesn't it like that? Right, a for each should... what am I doing? Consumer takes a path, so I'm using the wrong function. There's a capital E. So if we do a for each here, we're going to take the path that is coming in from this directory stream. We should be able to iterate over that and actually get all of the files in this directory. And so the idea here is, this might be a bad idea. But we can actually send the paths back. So we can actually do something like path dot toString to absolute path toString. Sure. And so the idea here is we get all of those paths. We can actually send them back along that to each of, or to whoever called this method. And so when I run world clone now, what I'm expecting is that I'll get a whole lot of these messages that will talk about every single file in that directory. And we should be able to use that as a way to sort of see where we are. We can't really connect a debugger to my knowledge. And so a lot of what we need to do to test this is going to be based off of logs or some other thing. And so that's sort of what we're stuck with. And so let's cancel. That seems to be done. Docker PS. Docker PS just lists all of the currently running containers. So we actually need to stop the previous one. There's a bug in my code, so it doesn't actually stop it automatically. That actually kicks us out of the other container as well, because we stopped the container, so we can't be execing into it. And so now if we go to send message, we should be good. We should be able to just run this Gradle Minecraft again. It's going to rebuild our plugin and create a brand new test world for us. And so that should go pretty quick. It can take a little bit for it to actually be able to connect to this, but that's just how this works. Most of this slowness is starting up the server. And so even if we're caching our Docker image or a Docker runtime, like if we were using the exact same server over and over again, it's just the slower part is actually starting the server and actually initializing all of that. And so we don't actually save that much time. So I just create a new world every time, but it doesn't take that long. So I haven't been that bothered. So eventually we'll get in and be able to actually see if this works. So hopefully what we'll see is we'll see a whole bunch of files get listed. I'm not sure if this is a recursive directory search, but it should return certain things. Let's try that again. All right. And so now we're in a brand new world again, just because. The handy thing with this is it means it's really hard to like corrupt your world. It didn't return anything. Okay, well that's unfortunate. Let's cancel that. Docker logs. Let's go and grab some of the logs from this. Logs-f that. All right, and so looks like there's some sort of error that happened here. No such file exists. So this doesn't actually work. Let's see, file systems. How does this work? I've never actually used a lot of the new NIO Java stuff. So this is something new to me. So I'm still kind of trying to figure it out. I don't know how to do an absolute path. Java git absolute path. Oh, well, that's easier. So let's do paths.get. We should just be able to give it the data path like that. So we can stop our server again and go into Docker PS. We're going to stop the one with the hash like that. Not add special symbols to the end of it. That should probably help. What does multi-MC do? Has a log system so you can see what is happening as the game loads. Okay. So mostly what I'm doing is I think we can just copy the entire data directory, and all I need to do is like swap a few bits to make a survival world into a creative one and give people extra privileges. I think that's all that's going to be needed. And servers can get kind of big, and so ideally I don't want to bring in the entire server, because starting up like a large server that's been around for a while is actually going to take a very long time. And so a lot of what I'm hoping to be able to do is like cut out as much as we can. But the first part is actually being able to get the data. And that's what I'm hoping to get done here. Oh. Do you need multi-MC then? Because I would assume... Oh, we haven't imported that. But with Java, you can, or with at least the Java Minecraft version, there's a launcher, so you can actually choose what version you want to run. Unless this is like a server side thing specifically, and then I'm less familiar. But, huh. All right. Let's see here. This might take a bit. Yeah. It will work eventually. All right. Let's connect to logs. There we go. Has it actually finished? I don't think it has. Yeah, there we go. So it needs to finish preparing the spawn area. Small worlds, this takes very short amounts of time. Large worlds, this takes forever. And so this bit is probably the longest of the entire like startup thing. And when we start dealing with like creating new clones of worlds, I think that's probably going to be the biggest problem we're going to have, is how do we create something that doesn't take forever to start. All right. So that sent us a whole bunch of extra things. It doesn't look like it's recursive. So this is the top level of that directory. And so if we actually want to like dig into this whole thing and iterate over every file, we're actually going to need to do something to do a recursive search. We can probably test if it's a directory and recursively like dig into it. That may be the best way. And that won't be too difficult. The other options are a little bit more interesting. We might just be able to pass this data directory off to some like tarball thing. How can we do that? Java tar a directory. Is there a built-in way to actually do that? I don't actually know if there is. And we may, I think the best way is to actually like tar the entire thing. And just like stitch a giant file together and throw that at some other like master server that knows all of these like creative worlds, that you, so that we can actually like recreate, and people who, like if you leave, what's eventually what's going to end up happening is somebody's going to run this command, create a clone of their world and leave. And we don't want those servers to just keep running, because eventually they're just going to add up and you're going to have hundreds of them. And that's expensive, and you can't actually like run hundreds of Minecraft servers on a single computer. And so eventually we want to shut down the ones that aren't needed anymore. And so something needs to do that. I'm thinking a server. I don't really know what that looks like, but that's sort of what I have in my mind. Let's see, what is this suggesting we do? Create tar-gz. Tar archive output stream. Is that actually a thing, or no? That's just somebody's example. All right. There's somebody trying to copy something. Is that actually a thing already? Or do I, what is that? Tar archive output stream. All right, that's part of the Apache Commons. I would really like to not import new things. So that's I think the big thing here. I don't want to like bring a whole bunch of stuff together and start like including all of these extra libraries, because that just is going to make this complicated. Ideally, I want some way for us to be able to just ideally I want to take a single like directory and merge it into a single file, which is what a tar would do. And maybe there's other ways to do this, or maybe we just export all the files individually, but that sounds like a lot of work. and I don't know if I want to do that. So let's see. What do they have to say? So this Stack Overflow is just going to open a whole bunch of files. Directory.get files, create another file, and then open each file and output it to that file. The problem with that is there's no distinguishing thing between each of the new files. And so you're going to run into this giant blob thing where there's just a blob and nobody knows how to handle this thing. So I don't think that's what we want. The other option, because there's always more options, we might be able to cheat a little bit. And so we could do that by using some of the programs already on this image. And so if we ls bin this, is tar, or yeah. So we can actually just use the process tar on our Docker machine and do all of the zipping itself. That may work. And so instead of doing this, how would this work? Let's see here. Oh, okay. So they're doing process start that. Just going to, let's see, process start info, and then process.start, and give it the command. Okay, that makes sense. Use, all right. So the idea here is we do some process start info. Is this a C# thing? This might be a C# thing. Hold on. Yeah. Java run a process. There we go. So the idea here is we're just going to invoke a process on our Docker image to do most of what we need. And then all we need to do is figure out how to tar a directory. And so we just say tar data. And it's going to say, I don't know what you want me to do. And so we're going to say tar something. What's the format? Tar C. And we want to compress using gzip -z. And we want to, I think that's it. Do something like this, and we want to put it at here /data/zipped_thing.tar.gz. Did I do that right? I don't think I did that right. Whoops. Well, that's just gonna keep going. Anyway, we want to do that, but not that. So yeah, this keeps somewhat separate for each instance. Okay. Oh, okay. So multi-MC is actually like if you have servers with mods, you can actually run. Okay, that's cool. This needs to stop. There. All right, tar. How do we export the file? Because that seemed to be our problem there. X file with glob. Nope. Tar -c -z and extract to standard out. I feel like we had another argument here that I'm missing. We'll just pretend. Okay, so that should do both of those. And then extract to standard out. No. Name of tar file. Got it. -c. All right. And we want to do the data folder and output it. I'm trying to understand tar. This is a mistake. I should not do this. Let's just look that up, but because I don't understand the tar command. Tar zip a directory. Okay. -z, c, and what else? And we want to go from this, the file we're outputting, which is going to be data/zipped Minecraft thing.tar.gz. We want to zip the data folder. And we probably should put it somewhere else. Let's put it in the root directory. Sure, what could go wrong? And so if we look at ls/zipped Minecraft thing, we want something a little bit more than that. All right, so that's the size of our zip thing. It looks like it's 65 megabytes or something like that. So we've effectively just created this giant package that is our Minecraft world. And it should be compressed. It's still going to be big because we just took the entire thing and effectively put it in a giant blob. But now we want to be able to reproduce that using this command, and then be able to send that off somewhere. So I believe, how does this work? All right, let's see if we can make this do what we want it to. Runtime, .git runtime. And then we want it to exec this. What was the command? Not that. There we go. All right, so we want to take this and run this command. Whoa. Not that. Well, I guess we can just retype it. -zcf, and we want to send it to temp mcclone.tar.gz. Cloned world? Sure. And so we're just going to copy it from the temp directory. I think that makes the most sense. And then we're going to put it in a temp directory. And so when we do that, hopefully we're able to do something. Doesn't like it because we can throw an throw an exception here. But that should be enough. We can comment out that directory crawl. We don't need to worry about that. And that's going to print out an error if we run into it. And so hopefully what I would expect is that after this is run, we will have this tarball in our temp directory, and we should just be able to access it that way. And so if we continue this, we should be able to docker ps and stop this. So docker stop that. That should kick us out on the right side, and everything should be good. Our code has been updated, so we should just be able to rerun this and get a new server. And then hopefully our command can actually access this tar command and run that. And then the next step after that would be just to upload this to some server somewhere, but we'd need the server. And so that's probably a future step. But for the initial goal of this whole project, I think where I want to get this is to a point where we can just create like a duplicate world. So it's going to recreate exactly what you had and not modify anything. I think that's like a first success. And then after that, we can actually start introducing extra like functionality. So if you want to swap from survival to creative, or from creative to adventure or something like that, that becomes possible. Or if you want to make yourself op or something, that might be possible. Or if you want to schedule this on some other computer that isn't the current computer, that might be possible. Not entirely sure how this whole thing is gonna work, but that's the general idea. So let's connect our logs again, just so we can see what's going on. Prepare and spawn. We have hello spigot, so that means everything is running. And we should be able to get back into it. Right. And we're in a new world again. I'm actually going to make this smaller, just so we can actually see what gets printed out to our console now that we're connected. And so if we run this, it may have worked. It's hard to tell. So the other option is to exec into it and give it the hash and then do bin bash. And so now we're in this server. If we do lsla and look at our temp MC cloned world, we get this other server. It looks like it's slightly smaller. This one is only 28 megabytes or megabits, so slightly smaller. But we did actually create that clone, which is good. It means that we can actually do things with it. And so if we actually want to like run an HTTP request and send this somewhere else, we have to send 30 megabytes, but 30 megabytes on a local network at least is nothing. That should happen in less than a second. And so we don't really have to worry too much about how much this is right now, because it isn't that much. When we get into bigger servers, it'll become a problem. But really all we need to do is take this and do something else with it. And so, is there a place we could see these files? I guess the next thing to do might be to just extract it. So we're using ZCF. I believe if we switch that C out for an X, we'll get something else out. I don't exactly know. What's the worst that could happen? ZX. Oh, well, I guess we can look it up. Yeah. So if we use tar ZXF and give it some output, I think this will work. MC clone data. I have that backwards. So we need to give it the file to extract and then the place to extract it to, which temp output, MC output, just so we are a little bit nicer. There we go. Not found. Why not? What if I don't provide that file? That may have been a terrible idea, but I think I just extracted it or did something. Again, tar is one of those commands that you use a lot and never really remember like how it works or how to use it. I think that was what we wanted. So we wanted to extract the file. That doesn't seem right. Do that. All right, there we go. What? ls temp. That doesn't seem right. That's something else. Where did we extract everything to? That's a great question. MC cloned. Yeah. So that's just the file. So I don't think we did anything. Oh, geez. Let's see here. File. All right. Decompress. C. Change to directory. Unless we... I wish this was clearer. I guess we look it up again. Let's see here. So I think everything that I know says that we can extract it this way and do something like that. But that's going to give us, it seems like that's going to give us a file from the directory. And so I'm not sure. ZXF. All right. What if I don't give it that? If I don't, so I think what the F does is it gives us a file and is saying extract to a specific file. I don't think we want that. I don't think we want to extract a specific file from the archive. We actually want to extract the entire thing. But then it locks up because I think I just extracted it all to my root directory. So we would instead want like mc clone or something like that. But I still think that isn't exactly what we want. But let's see if we add a v flag, that'll be verbose. And so we would expect it to print out a little bit more, but it doesn't. So I feel like it's stuck. Or I'm giving it some really bad thing because like the directory that I'm pointing at doesn't exist anymore. So something's going on. I don't know what though. Okay. Apparently all I'm missing is an F here, and that should extract it locally into the temp directory. Or did it extract it here? Let's try something else. Let's make a directory and call it test. And we'll cd into the test directory and try this again. Yes. All right. So that's what's happening. It was extracting to my working directory. And so now inside of this test directory, we have it, which means I might have been overwriting my server data a few times. So oops. but there we go. So we actually do have working extraction of our data, which means we can actually access this stuff and actually do things with it. And so I think that's really what we needed. I don't really like the idea of invoking commands. This makes the entire code base really fragile, and that isn't great. So the problem with doing this is if we don't have a tar command on whatever environment we're running this on, it won't work. And because we're using a specific image in our current world, that isn't going to happen. We're always going to have this tar command. But if you were to run this on Windows, I don't think we do have a tar command. Actually, it looks like we do. Okay, cool. So that does exist, but depending on the system you're on, that may not exist, and the syntax may be different. And so in that case, things may break. And that's not going to be something great for deploying elsewhere. And I don't want this to rely on everybody having to use a Dockerized initial server, you should be able to plug this on top of any server and it should work, as long as you have a Docker environment where you can run the clones. That's the goal. And so I think the next step for me offline is probably to go and find something that can do this tarring in the least heavy way possible. So we can actually create these zips and send them off somewhere in a very small format without having to do a lot of extra work, and then hand that off to something else to actually spin up new images, and then eventually report back and say the server was created, you're good to go. I think that's all we need to do. But I think I'm going to leave all of this here for now. We've been streaming for about 5 hours now. And so I just kind of wanted to explore this because this was something that I didn't really know how to do. And it seemed like it was a good place for this. I don't know. Yeah, I guess this project is seeming like it's going to be more complicated than I had hoped. Just because inside of Docker, there's a containerized environment is somewhat isolated from everything else. And so taking things in and out of that container is difficult. And so the problem we run into is if we're running our initial program, our initial Minecraft server inside of this containerized environment, we actually can't schedule new containers from it. We would actually need to be running outside that container because containers can't schedule more containers inside of themselves, because then you just get this recursive thing, and that's not great. And so we would need something else to be able to like reach out to and say, run this thing with this data and this configuration. And so maybe we can find something that will allow us to do that. Otherwise, we need a server that is like organizing and operating over all of this. And so I'll figure that out in the next bit. But I think we're done for tonight. And we will pick up either tomorrow or some other time. I don't know if we'll do more of the platformer stuff or more of this or something new. But that's pretty much it. So yeah, thanks for tuning in and hanging out. It's been fun. It's been very long, and we've done some cool stuff. We got less done than I had hoped. The platforming stuff took longer, but we got to a good place in the end. If you just recently joined, this is what we were building previously. So it's a platformer controller. It does some movement controls, and so you can kind of move around. It's using our own physics stuff. So there is a rigid body attached, but we don't actually use the rigid body for much of anything. It's mostly just there so that we have a way to track a moving body in our scene. Everything else is actually handled by all of those points you see. Those are a bunch of gizmos kind of simulating sort of the velocity and checking to see if we're going to hit anything in those specific points. So like we can't run through these walls or go through the floor, and jumps work. So that's what we've done previously. Yeah, if there's other things, I don't know what else there could be. But yeah, I did leave a link to our Discord if you're new here and you wanna come and chat. We do have a Discord. Come and join it. There's lots of cool people there, and we talk about all sorts of fun things. And so yeah. Other than that, I think that's mostly it. So thanks for joining in, and I will try to get the VOD up. But other than that, see you in the next video.